Hey Girish, good morning. The live stream is on. So I would, how do you call that? I would recommend that maybe you can mute your Skype and check on the live stream if everything is fine. And then you just show me a thumbs up if the audio and the video quality is fine. Et tout le monde qui est connecté avec nous en ce moment, bonjour et welcome to Virtual Developers Conference.
I think that one of us should mute their mic when talking because there's still a short echo. Let me talk and listen to it now.
Okay, we'll do that.
Great. So hello everyone, good morning to Developers Conference Day 2. We are just doing a test run this morning to not face the problem we did yesterday. Hope that it all goes well smoothly today. So how is it, Ish? All good? So how is it? All good? Yeah, I think it's good. I just listened to it. Also, I should maybe try a echo cancelling speaker. Maybe try see if that works. Wait. Speaker. And yeah, I need to change the settings in Azure to use Crisp. Great. So yeah. How is it now, Ish? Maybe you should talk and see if the echo is still on.
Wait, Girish, I think, can you send me the link to the live stream? I had the wrong one.
Yes, wait.
Send me on Telegram.
Yep. Done.
And then we do the test again. Okay, I'm gonna mute. You keep talking. Do some introduction.
Wait, I actually listened to when I was talking. It didn't have any echo, but when you were talking to me, there wasn't an echo. So maybe that's a problem from my side. So I switched to the crisp speaker. Maybe you should talk again and let's test if it's working now.
Okay, let's do that.
Yeah.
Let me know when I should start testing.
Maybe you should already be talking.
Okay, so good morning, everyone. This is the Virtual Developers Conference. We are doing some live testing so that we do not encounter any problems in a few minutes when we start. Et tout le monde qui est connecté, bonjour et bienvenue Virtual DevCon.
Ish, I think we are going to have a great day. It's all good, clean. Yeah, great.
Allez, now let me, you talk. I'm going to mute my microphone and I'm gonna listen to the live stream. Okay?
Okay, great. Yeah. So once again, hello everyone. I won't say hello Mauritius. We have people all around the globe watching us. So hello everyone, good morning. It's DevCon Day 2. We hope that this goes as good as it should be. We don't get the problems that we had yesterday. We are already live and yeah, we'll be starting at 9. So this is already a test run that we will be doing. So Ish, how is it? Good? I don't think we have much delay as well. I think it's pretty much instant, right? Maybe a few seconds. Well, I don't know what to say now. The speaker's already in touch. So,
that was awesome.
Great. Pas vraiment un lag, non rien. Delay, no much.
The video delay is maybe a few seconds compared to the last day. Nous avons de 6 à 10 minutes et une fois nous avons même 12 minutes. Et video quality is okay. I think this is what we're going to do. You introduce the speaker and then I take over pour faire you know the speaker. Audio mixer. Scene change. I'll do the scene change. Pardon?
We'll invite a speaker, one of our friends,
Uh,
or
uh, who do we have as first speaker?
some. Yeah,
We
we
have
have Stan.
Jeshta, I think. Call Jeshta. Mute your microphone, call Jeshta. We do a test with her.
I already talked to her this morning. Okay, maybe I
Yes.
should.
Just
I
ask
told
her
her
to
that.
come and we do a 5 minutes test or 2 minutes test, and then she will start at 9. Is that so? While you're calling her, just mute your microphone so that we don't get the interference. Okay.
Okay, yeah, so she will be with us soon.
She's joining in a few minutes. Meanwhile, I'm letting uh, wait. I think there's a message from our friends. Is Ishan some? Uh,
Asking how are you using the auditing thing? You're using a Mac, right?
no, I'm using a Windows laptop. I see Yoki already answered that. So what I was saying that I'm posting on my social media accounts, Facebook and Twitter, that we are live from Kryptone at the Mauritius software. Wait, sorry. We are live from
DevCon.
Kryptone, DevCon MU, Mauritius. Uh, our first speaker for today will start at 900 hours MUT. Okay, we just make it fancy with a smiley,
We already have it.
and then we
Yes.
put YouTube link, and that's it. And voila, this goes on Facebook. I'm just gonna let our friends also on Twitter know about it. So,
That you're using.
why is Neil shocked that I'm using a Windows laptop? This is what I don't understand about my friends. It's as if I don't know, when I use a Windows laptop, it's like I'm changing religion or whatever. Come on, guys.
That's something shocking that you're using Windows. You're such a
And
big Linux fan. Yeah.
Girish, I'm such a dumbass when I use Windows. There are, small things that I can't do. Maybe even configuring the sound settings or the microphone settings. It's like a pain for me.
Oh, well, you're not used to it. That's why.
Okay, so
You always.
I'm just gonna ask our host friends if they can test the live stream and confirm that there's no problem in Krypton. Hey guys, can you check the wait? How do you call that? The Krypton live stream and confirm us the quality is okay. So that's it. I think we wait for our speaker to join in. We do some tests, and then we should be good for 900 hours. Correct, Girish?
Should I do it now?
Yeah, Oscar to join.
Yeah, maybe play the Spencer loop. We do it on our side first and we go live.
All right, folks. Have a look at our sponsors, whom we are very grateful for making the Virtual Developers Conference happen. Here it goes. Um, Hey Girish, we are live. I leave it to you to introduce our next speaker. And I just to confirm everyone, this is just a test right now.
Yes. So yeah, maybe we should start practicing using our microphone. Yeah, you already did that. Great. So we have with us our first speaker of the day, which is Jester. He is a backend developer at LSL Digital. Um, yeah, Jester will be talking about design patterns for modern software. This is only a test, guy. Maybe she will just do a short introduction on what her talk will be about, and then we will start at 9 o'clock. Great. It's all yours, Jester.
Hello everyone, my name is Jeshta Reda and I will present on modern, let me just design pattern for modern software, which is a pathway to elegant problem solving and coding. So I'm a software engineer at Consulting Ltd. So what to expect from this presentation? So I won't be talking about algorithm, if as group and all those stuff. No application building, nothing about bringing in the problem like doing an app with it. So we will concentrate much on designing reusable and extensible software using OOP. So in this presentation, live demos using the language PHP and Golang. So I will run the code to give you a detailed description of everything that I will be talking on. So what is a design pattern? So this is a solution to general problem that software developers have faced during period of time. There are different patterns to do different things, and it's taken from brilliant mind from tons of different people that have come together and said that this is the best way we have in order to do this problem in the cleanest way possible. And that's really what design patterns are really, for making your own code cleaner to use, to read, to be less buggy, less error prone than if you weren't using any of these design patterns. So personally, learn to learn the design pattern is fairly straightforward.
Hey Jeshta,
And
can you hear?
yeah, yes,
Jeshta, can you hear?
yeah, I can hear.
Yeah.
Jeshta, can you hear us?
Yes,
Okay, that's fine. It was a very good test. I think you can take a 5 minutes break. Just stay online. 5 minutes break. Uh, I'm gonna put us back on the Spencer loop. And friends, stay tuned. We're going to start exactly at 900 hours today. Girish, I leave it to you.
Yeah. So maybe you should already play the Spencer loop, or
Good morning, folks, and welcome back to the Virtual Developers Conference 2020. I am Ish Sukan, and along with me, there's my friend Girish Mahabir, co-hosting in Kryptone today. Girish, over to you.
Good morning, everyone. We are really happy that the stream is good today. Hope that we don't face any problems that we did yesterday. We already have our first speaker with us, but yeah, let's wait a few minutes. Maybe, yeah, we only have 1 minute left and get the
Yes,
DevCon going.
no problem, Girish. Our next speaker, Jesh Tabuido, is already ready. I'm adding her. It should be like 2 seconds thing. And 3, 2, 1. Here we go. We have Jeshta on us live. Good morning, Jeshta.
Good morning, everyone. So
Yeah, so
today I will.
let
Okay.
me
Sorry,
introduce.
Girish. Yes, I was telling you. Maybe you do the introduction.
Yeah. So Jeshta is going to talk a bit about design patterns for modern software. Jeshta is also someone that's working as a backend developer at LSL Digital. She's also a winner of Web Cup 2018. We're already pleased to have such a person with us today. Not tonight, seriously, good morning. We are really pleased to have such a person with us today. Yeah, so Jeshta, maybe talk a bit about yourself first and we get started with our talk.
Hello, everyone. I'm just Bedo, National. So I code primarily using Go language and PHP. So whenever I'm not coding, I'm just watching anime and reading mangas. So design pattern for modern software, a pathway to elegant problem solving and coding. What to expect from this presentation? No algorithm, nothing about if and else statement, loops, nothing, no problem, no application building, and we will focus only on designing reusable and extensible software using OOP. So what are design patterns or solution to general problems that software developers face during development? There are different patterns to use to do many different things, and it's taken from brilliant mind from tons of different people that have come together and said that this is the best way that we have in order to do this problem in the cleanest way possible. And that's really what design patterns are really for making your own code cleaner to use, read, less buggy, less error prone than if you weren't using it. So personally, a learning design pattern is fairly straightforward and easy things to do. But actually, the learning process is easier than learning when to use it. Because the biggest problem that people have when using design pattern is that when they learn about them, they are like, wow, this is amazing, and uses them to make their code so much cleaner, and they start throwing design pattern in areas where they are not needed, they are not fit, or they may just be an overkill. So not using them would be much better. So therefore, learning when to use them is hard, but it is worth it when you have more storage. So why design pattern? Reusing design pattern help to prevent subtle issues that can cause major problem like less buggy code. These pattern has already been tried and tested, which generate and improve code readability for coders and architects familiar with the pattern, which is better communication. Many frameworks like Angular, React, and Vue use them. Vue has a state management, which is a state design pattern to implement its single source of truth principle. And it is an efficient and really reliable way to use the concept of OOP, object-oriented programming. So, history, this for gentlemen, Ralph Johnson, Richard Ernst, Eric Kama, and John Vliside are the superheroes who invented the design pattern. If not, designers and developers would still be wandering here and there, wasting time and efforts to find various solutions to recurring problems. Types of design pattern. So we have 23 design pattern, which is categorized in creational pattern, structural pattern, and behavioral pattern. So creational pattern are all about class creation and object creation pattern. It provides various class and object creation mechanism which increase flexibility and reuse of existing code. Structural patterns are all about class and object composition. Structural design pattern is designed by identifying a simple way to realize a relationship between entities. And behavioral pattern are most specifically concerned with communication between objects. Design patterns categorized in creational, behavioral, and structural. So in creational, we will talk about singleton, builder, and factory method. Structure will be adapter, and behavior will be command design pattern. We start with the first one, singleton. Singleton, in simple words, it is used to limit creation only to create only one instance of a class. It provides only one global access point to that object. In other words, a singleton encapsulates a unique resource and make it readily available throughout the application. And we can say that singleton acts as a command, ensuring orderly access to the shared resource. So when should we go for a singleton? When a class has no attribute, so it has no state, and we are passing value as a method parameters. And the second case is when the case is a read-only state. So the anatomy for PHP singleton. So you need to have a private constructor to prevent direct creation of object from the class. And all expensive process is performed within the private constructor. There should also be a static method to create an instance from the class. The object will be created only if it wasn't already created. Let me give you a little demo on. So this singleton, yeah. So we have taken an example of a database connector, which is our singleton class. So we have a constructor here, which is private to prevent initiation with outer code, and all the expensive process is made here. The object is created from within the class itself, only if the class has no instance. So we have checked if it is already connected, already have an instance. If yes, it will make a new database connector, and else it will return itself. So I have two objects trying to connect to a database connector, and there is a check on if these two objects are the same. So database connection initialized only once, and it has written bool true. So it is the same instance. Next, we will do it in Go language. So now in the anatomy for Go, it has multiple ways to implement a singleton. Two of them are init from, and the second is sync.once in sync package. So in the package init, it is guaranteed to be called only once, as it will be run at when it is building. All call from a single thread, and lastly, they are thread safe unless you make them single threaded. And the second one is sync.once. So sync.once the do call the function if and only if do is being called for the first time for this instance of once. In other words, do is intended for initialization that must be run exactly once, and that's exactly what we need for our singleton pattern. So the anatomy for we'll just use the init method and sync.once. In this, we have to define our single object as private, create our global variable as type pointer to the single object, and declare function that provide a global point of access to that instance. So we check it in Go. Right. So we have our main singleton. So this is this one is implemented using the init. So we just have to call the init function. This is my singleton object and the global variable of type pointer. And this get instance is used to return the instance of our singleton. So if I have to run this, okay, so main with init, test it with init first. Let me, So initializing singleton A, and we have twice, we have this creation of singleton instance, X and Y, so it's the same. We have initialized it only once. Now with the sync package, okay, so in this case, we have a manager, which is our singleton class, and our global variable of type pointer, the sync.once, which is the struct, and the get manager. This once the do function ensures that the singleton is only instantiated only once, and these are the helper methods. So let's test this one. So initializing, no, we sync. So using sync.once, and the first creation is to check the first creation. We have instantiate it to be off, and the state manager try to see to check if it's off. If it is, it will set it to on. So here it is, and the latter do the reverse. So the output is the state is off for the second creation. The next one is a builder design pattern. So So the objective, builder pattern is used for constructing complex object, is used to create object made from a bunch of other objects. So when do we use a builder? When the object constructor is big and requires multiple steps, then it helps in less size of constructor. Secondly, when a different version of the same product needs to be created. Next is when you want to create, you want creation of this part to be independent from the main object. Fourth is when you want to hide parts of creation of parts from the client, so both are not dependent. Then only the builder knows the specific and nobody else does. So it might sound a bit complicated, but it is rather simple. Okay, not simple, it's okay. The anatomy is the same. We need to have a builder interface that represent a high-level abstraction on the actual object graph carving. Concrete builder class, which is an implementation of the builder interface, different builder implementation. fourth is we need to have a director clause that calls the appropriate builder and return it. And lastly, the final product of the concrete builder's work. Let's say a case example. Let's say the client wants to have a burger, which can be veg or non-veg. Both versions of burger are different. So when using the design pattern, we'll have to create a burger builder interface, a veg burger builder, and a non-veg burger builder, which is a concrete builder, implementing this burger builder interface, and our director, which is a burger creator, which will call the appropriate builder and return it. Let's check it in PHP. How are we going to implement? So I have my burger class. This is my builder interface. It provides the method for preparing the builder, and the get food will return the final object, which is the burger. So we have two concrete builders, veg burger and non-veg burger builder. Both implement burger builder. As you can see, all the methods are being implemented. So, and the director, which is the final piece in this design pattern. The build burger's main responsibility of the director is to get the builder interface and call the builder method, then retrieve the object. This is the builder interface and the builder method. So here it is returning the object. So if we have to test this, so we have to create firstly the director instance, initialize our concrete builders, and build our burger. So if we test this, so we have our two burgers being built, veg and non-veg. Now in the case of Go, yes. So again, we have this interface being the burger builder interface, our concrete builders, which implement the burger builder, and our director. So please note that I have a helper method set burger because I don't want to create the director again, so just have to use a set burger after making an instance of a new director. So if we have to test this, so testing this one. So, okay, I have get the instance of the burger builders, created a new director, and build the burger. And this is the helper method used in order not to make another instance of director. So we have tested this part of code and so that it's working and using this builder method. The next one is factory method. Factory method provides a way to hide the creation logic of the instance being created. It also allows creation of various types of objects without necessarily knowing what kind of object it creates or how it creates. So when do we use this one? When you need to provide a high level of flexibility in your code, when you need to centralize the class selection code, when you need to encapsulate object creation, or when you don't want the user to have to know every subclass. So we go directly to the case example. So we have, in our example, we have a vehicle interface which defines the method a vehicle should have. There is a vehicle clause that implements this interface, and we are going to have two concrete clause, which is Toyota and Laurent Hudson. And we are going to have the vehicle factory clause, which will create the vehicle of type car or ship. In PHP, we'll use index.php as a client instead of directly interacting with the car or ship clause. it relies on the vehicle factory to create instances of core or ship. And in Golang, we'll use the main.group as the client. So let's hit out. So we have our vehicle interface. It's defined all the methods a vehicle should have. A concrete class of class core and ship, which implements the vehicle interface, and the vehicle factory. So if I want to create a class of ship, we just have to call this create method, and it will return the appropriate class. So the client is, so we create a vehicle factory, create the vehicle object, and use the vehicle factory.create to get the instance of core or the instance of ship. So if I have to try this, so it's by using the vehicle factory of core and of an object of ship. Now if we have to do this in Go, so in Go, again, this is the interface and the method. I have the vehicle class here, and I have made ship and core embed. The ship struct has embedded the vehicle struct, and hence both ship and core can indirectly implement all the method from vehicle interface. So I don't have to implement these method again. So it's as you know, Go does not do inheritance. So we do composing class instead of inheriting. So to test this one, so I have two object core and ship using vehicle factory, and let's see what it gives us again. So this one, this Toyota is returning the vehicle Toyota Corolla, and the ship is returning Ocean 3 Cape, which is of type ship. So this design pattern is implemented successfully. The next one is adapter. Adapter, okay, let's see the benefit of factory method first. If you need to change, rename, or replace a vehicle class later on, you can do so, and you will only have to modify the code in the factory instead of everywhere in your project that uses the vehicle class. And secondly, if creating the object is complicated, you can do all the work in the factory instead of repeating it every time you want to create a new instance. Now the structural design pattern. Adapter. Adapter design pattern is responsible for adaptation of two incompatible interfaces, but the inner functionality should suit the need. Like if you have an interface which is incompatible, the inner functionality must be the same as the other interface. So it is responsible to join the functionality of independent or incompatible interfaces without modifying their implementation. And adapter also allow impedance match an old component to a new system. That was what I was talking about in the functionality. Yes, okay. So when do we have to? When the object implement a different interface as required by the client. So it is much more simpler by using A case example, we have a class, which is a customer, that is expecting some features of an object, which is a pay hub. But we have another object called adaptive, which is payment, which offer the same functionality but through a different interface. So the anatomy for Go and PHP, we need to have a target, which is an interface, pay hub interface, payment to pay hub adapter, which adapt to the target interface, and adaptive, this one, existing interface that needs adapting, and a client to collaborate with object conforming to the target interface. So in PHP, if I have to do it in PHP, we have this adapter. Okay, this is how we do it in adapter. So the problem statement, the customer can buy item and pay with PayHub as the buy method takes in parameters of PayHub interface. But what if the customer wants to buy item and pay with a different interface payment? Then errors will occur. So we need to adapt payment as payment offers the same functionality, but through different interface. Add one item and at price to total. These two are the different methods implemented by payment. But you can see that the functionality is still the same with PayHub. So we need an adapter. So payment to PayHub adapter implements PayHub, which is the interface. So in order to hold reference, we need to pass a new class object through the constructor, and the adapter hold a reference to the new class. And the name of the method of the old class is still being kept here, but this class has already implemented PayHub. As you can see, we have this method add item and add price, but we are using the methods of the payment. So let's test this. Okay, this is our adapter. This is our adapter, and the customer wants to pay using this this adaptive. So we test it. Okay, one item added lollipop, and the price is 2. So it's good, it's working. Design is done. It's good. So I have to do this in Go language. The same anatomy is being followed. I have my customer, which want to buy using the IP hub interface, and the payment here, which is the adapter, which implement the IP hub interface. So the adapter, so we have implemented the whole class interface. Here, still the same as in the PHP. So let's just this one. Yes, adapter, and client. So this one is using PayHub directly, but this one is using the adapter. Let's check how it is doing. It's working perfectly. So this is the adapter design pattern. The next and the last is behavioral design pattern. Behavioral design pattern. So in this command, let me present it. So In the command pattern, an object encapsulates everything needed to execute a method in another object. So it is pretty common in PHP. This command pattern is pretty common using PHP. It is used for queuing tasks, tracking history of executed tasks, and performing the undoable task. And command design pattern focuses on following question. So what clause does it consist of? What roles do these clauses play? And in what way the elements of this pattern are related? And if let's see, yes, basic component for behavioral command pattern is one should have a receiver, a command, an invoker, and the client. This is a basic component. So the receiver contains business logic. Command object only delayed its request to the receiver. Command embeds a receiver and binds it to a particular action of the receiver. The third one is invoker, which embeds command and invokes command by calling the command execute methods. And lastly, client, it creates command with appropriate receiver by passing the receiver to the command constructor. It also associates the resulting command with an invoker. So when do we use this design pattern? When you need a command to have a lifespan independent of the original request, when you need to do undo redo operation, the command's execution can be stored for reversing its effect. And when you need to structure a system around high-level operation built on primitive operations. So the anatomy for command for both PHP and Golang is pretty much the same. You have to define a command with a method signature like execute, create one or more derived clauses that encapsulate some subset of the following, like a receiver object, method to invoke, the document to parse. Third is you have to instantiate a command object for each deferred execution request. Fourth, pass the command object from the creator, aka sender, to the invoker. And lastly, the invoker decides when to execute. So let's see how it is done in PHP. Come on, here is it. So the interface command, a clause order that implements the command interface, a clause waiter, which is the invoker, and the chief is the receiver. Yes, so this is our interface. The chief is the receiver. It has two methods, cook, pasta, and bake cake, and our concrete prototype, which is order. Order implements the interface command, and it also has this execute method. So even yes, the waiter implements the I command. So if I have to testing this one, we have to create an instance of chief, an instance of order, which takes in chief and the action that has to be made, and the order is the waiter takes in the order. So let's check this one. Okay, the chief is cooking chicken Alfredo and the chief is baking a blueberry cheesecake. So this is how it is done using the PHP method. In so here it's called so in yes. So in for Go, okay, we have our chief, the command interface, which implement only one method execute. The chief is the invoker and receiver. Our order and this waiter, which is the invoker. So let's check it. If I run this piece of code, so yes, an order is placed to the chef. The attendant takes the order, which is our waiter. Yes, the chef is cooking chicken Alfredo and the chef is baking blueberry cheesecake. So it is doing really good. So this is how it is implemented using Go language. Okay. Okay. What is the benefit linked to this command? Command decouple the object that invokes the operation from one that knows how to perform it. It's easy to add new commands because we don't have to change the existing clauses. And lastly, a command can be assembled into a composite command. So this is it. I wish I could talk about facade. I already have the code for facade, but we already have. Yes. Okay. So yes. So to conclude, there's a lot of useful design patterns that I have tackled, but I have tackled some important and most used design pattern. And learning how to implement design pattern is easy by learning where to use and but learning when to use it is pretty hard. Practice makes perfect. One should pay attention when using design patterns, as a developer needs to adapt the design pattern to his problem and not try to adapt the problem to the design pattern. So this is it. Thank you for watching. Please don't forget to give feedback. Any question?
Yeah, we are actually monitoring the live. There's no actual question, but there was one guy that maybe asked you to zoom a bit on the VS Code font.
Yes, which one? Okay. It's already my bad.
That's fine. Maybe if you're muted.
So this code, I wish to say that this code is will be made public. So please tune on my social network, and I will make this slide and this piece of code public on GitHub, and you can view it, play with it in any way that you want. Sorry for not zooming the line of codes.
That's
Yes,
fine.
I cannot hear you.
Can you hear me now?
Yes. Yes. Yes.
Yeah, so
Yeah.
I was telling you that thank you very much. In fact, it was only at the end of your presentation that we got a message about, the font size, but that doesn't matter since you're saying you're going to share it, the code on GitHub. Probably you send us the link so that when we process your video and upload on YouTube, in the description, we can also put the link to your GitHub code. And thank you very much again. It was a very nice presentation. Jeshta, would you like to shout out to all the fans that are listening? And wait, sorry, just need to do something. Maybe if you would like to shout out to all the fans that are fans of MSCC who are listening, who are watching right now, and any special words to them?
Keep watching, keep learning, and keep cheering us also, for us speakers to continue to work harder for
Okay,
our next
Jeshta.
presentation.
Thank you very much. Girish, maybe a few words before we switch over to the sponsor loop.
Yeah, very nice presentation, and the fact that you will be sharing the GitHub link later would be useful for the guys that couldn't see the font. So yeah, that's all, I guess. Maybe we can wait a bit before our next talk would be at 10 o'clock. It would be on Golang from zero to hero. So see you guys at 10. I guess that's it ish.
Yes, thank you very much, guys. See you in about 20 minutes. Hey guys, welcome back to the Virtual Developers Conference. We are live. I'm Ish and my co-host is Girish. We have Yusuf and Jules along with us. Girish, over to you now. Girish, you need to unmute your microphone.
Yeah, everyone who is not talking is mute their mic. Okay, I have found that there's an echo right now. Okay, good. So we have with us two amazing developers, Yusuf and Jules. Yusuf, who is a senior backend web developer at La Sentinelle, and Jules, who is now working at Shopee, who is also a senior web developer. So yeah, maybe Yusuf could start by talking a bit about himself, and then we hand on to Jules, and then we start the presentation. It's all yours, guys.
Okay, hello, I am Yusuf. Actually, I'm a backend developer at Shopee. I have been working with Go for quite a while, and together with my friend Jules and other people, we have started the GoFirst.mu user group, trying to promote usage of Golang in Mauritius. That's about it for me.
Hello, I'm Mike, also known as Michael Go Online. Yeah, can you just wait? Okay. Also known as Michael Go Online. And I'm a senior web developer at Bocase. I've been working there for a few months now. It's been really great. As Yusuf just said, we started the Go user group in Mauritius. And our main goal for today is to present Go to you and how it is easy to make modern web applications in Go. And that'd be all for me. Okay, so first of all, as the title says here, it's Golang from zero to hero. The objective of this presentation is to allow you to get a good grasp of Go and to understand what is Go and how you can use Go to create different services, especially HTTP services, to aid you in your development or at work or on any project you might be on. So first of all, why Go? People might be wondering, we already have a lot of great programming languages out there, but why Golang? Why would you choose Golang? And there are some few reasons why Go is a great fit for your enterprise applications. Go is a compiled language, which means you have a compiler. Compiled language are known to have fast execution. And Go can also cross-compile to different operating systems and architecture. This makes deployment a breeze with Go. With Go, you don't have any runtime dependencies, meaning you don't have shared libraries or things like with other applications you would have when you ship your application. It compiles to a single binary. So every library that is required for your application to run will be compiled in a single binary for you to use. Also, Go is a strongly typed language. What we mean by strongly typed is it's easier to detect errors ahead of time, especially errors that has to do with type errors. For instance, trying to assign an integer to a string variable. Go allows you to spot those kind of errors in advance and make for a swift development experience and less errors at runtime. The third key aspect of Go is it has a lightweight syntax. There's a limited set of keywords, and the language has been built to be easily read and easy to write. If you look at the Go spec document, you will see that it's very easy to go through it. It's only a few pages, and this will let you grasp why we like Go because of its minimalistic features. And Go is highly concurrent. Go allows for concurrency. we have channels in Go, and we have what we call Go routines. Go routines are lightweight threads. And to communicate between those Go routines or to synchronize those Go routines, we use channels to communicate among them. And Go is easy to learn. If going back to the lightweight syntax, when you write Go code, when you read Go code, you will easily see how of a better developer experience it gives you in that regard. And Go has great enterprise support. For many popular platforms, there are SDKs, there are libraries to perform different tasks in Go. And this makes Go running in the cloud a great experience. If we go to the next slide, you will see a simple hello world example in Go. Go code is organized in packages. Here we have the main package. To import those packages or libraries, as some fellow developers will call it, you use the import syntax. So import, and you specify the name of the library or the package, or the path to that library or package. Every executable needs an entry point. In our case, this entry point is denoted by the function main. So as you can see, we have a func main, and in the body of that function, we have a single line of code. To explain this single line of code is from the font package, as we like to call it, the FMT package, we are importing a function that prints with a new line. And that function takes a single argument here, which is a string, hello world. So this is your simple hello world example in Go. Now going on to more syntax explanation in Go. As you can see, if we go to the left-hand side screenshot, we still have our main package, but now we are importing more libraries. And since we are importing a lot more libraries, we can do what is called a grouped import. So we just have to specify the import syntax, and we have the brackets, and inside of those brackets we have the various libraries that you will need to import. On the few next line, you will see how we declare constants in Go. Here we are declaring a card threshold constant with a float number of 100.00. When declaring like this, Go already knows that this is a float number and will make card threshold a float 64, depending on your architecture. Same as before, we have our entry point, which is function main. And in function main, we have some few computation that we are doing. First of all, we're declaring a count variable, and we are assigning it an array of float 64 values. In this array, you'll see that we have already defined some of the values in here: 10, 5, 1, 0.5, 0.25, 0.10, and 0.01. Actually, this is slightly a lie, because this syntax that you're seeing right here is not actually for declaring arrays, but most likely to declare slices. Slices can hold a variable or a flexible amount of values in them. After which we are declaring an array, this time with a fixed number of elements, integer element of 7. And we also have a short syntax for declaring variables, where you don't have to specify the var keyword in front of the identifier. This can be seen with the amount, when we are assigning the amount variable. You will see that we have a colon equal to a 107.50. This is an assignment with type inference. In our case, it will be a float 64. We also have the ability to group variable declaration together, as we have seen with messages and gets coupon. Messages being a slice of string, and gets coupon deriving its value from an equality operation, checking if amount is greater than guard threshold. On the top right screenshot, we see an example of a loop. In our case, this will be a for loop. And on the same line as we have the for syntax or keyword, we are assigning I to a value of 0. Few characters later, after the semicolon, we are checking if amount is greater than 0. This is our condition while looping. And we have our incrementer after the semicolon, which is I++, which simply signifies that we are incrementing the value of I with each iteration. As you can see in the comment, it's a loop with an initialization, a condition, and an operation, as you would find in other languages. And the two lines afterward are just dealing with conversion. We can see how conversion happens in Go. And then at the end, we are appending those, we are doing font string F, which is just string formatting. And we are appending the result of the font string F to our messages, to our slice of messages. And in the last screenshot, the one just below it, we see an example of a switch statement. In this case, we are switching, or we are checking for the weekday. We are doing a time.now to know what is the date today. And we are specifically requesting for the weekday. And we have different case. We have a case for if it is Saturday and Sunday. If it is both Saturday and Sunday, which is we have grouped those cases together, it displays it appends a nice message saying, hope you're having a nice weekday. And we do the same for Friday and Monday. But you will see for Monday, we have an explicit fall through. In Go, the break is implicit, so it doesn't fall through. But for Monday, we are explicitly fall through. What fall through means is we are falling through to the next case. For Monday, we are falling through to the default case. Which happens here is for Monday, we are saying, say we have coffee in the lounge, and we are falling through right afterward to the default case where we are appending the message, say, have a good day. And at the end, we are printing all those messages separated by a new line break. In Go, we have first-class functions. What does that mean? Very quickly, is functions can be considered as values. We can assign them to variables. In our first example, in the top left example of getDoubler, you can see that we are returning a function here. And that function can then be used everywhere we need it. For instance, if we look at the bottom left example, we are using that same function, getDoubler, or just to clarify on some stuff, if you look at the getDoubler function again on the top left, you'll see that it actually even accepts a function and returns a function, which is something very impressive. And for even doubler, bottom left corner, we are passing in an anonymous function, which means a function which does not have an identifier as our mapper. And we are then returning another function. This same example can be seen on the right-hand side of your screen. In Go, we can also have variadic functions. What we mean by variadic function is we can have a list of similar type arguments or parameters to a function. FuncSumAverage, as you can see, accepts a list of numbers. In our case here, that would be a slice of numbers of type integer and returns two values of type int. There's no need to go through the body of the function, but what is really cool about it is this is done through the spread operator, and we can have many return values as we've seen. The spread operators is denoted by the three dots before the type. And in the next screenshot, the bottom one, we have a numbers variable using the short assignment, which accepts a slice of integer 1, 2, and 3. And then we print the sum average of those numbers still by passing it in the function above using the spread operator. In Go, we can say that Go is somehow object-oriented. This is a very debated topic. If we look at the first screenshot on the top left corner, you would see that we create a new type, a type person of type struct. This type person can hold different properties, as we would call it. Those properties are name and wear glasses. Name is a string and wear glasses is a Boolean value, true or false. And how can we do object-oriented in Go? We just assign a function or a method to that person struct. And that method here is a string method we are applying. So we have func p person p denoting the instance of person, instance object of person, and string just being the function that we will create in that instance or method will create, and it will return a string. And this you can see in the body of the function where we're just doing some string formatting with my name is and using the property of person, which is p. In the bottom left corner, you will see two more examples of object-oriented in Go. We have two struct. We have the animal struct and we have the employee struct. Same as for person, we are attaching two methods to them or two functions to them, which is a string function. And that string function returns a string for each one of them. And the body is the same. We're doing some string formatting. So you can see that for animal and you can see that for employee in the body of the various methods. In the bottom right hand side, we have this. We show how we can create objects from the structs that we did before. Here we are creating a John object, and for that John object we are assigning the name property to be John, and then we are putting it with a new line. Just below that screenshot, we will see a more advanced example of how we can assign the various properties of employee. So we declare an employee object, emp in our case, and we are doing various assignment. So emp.wearglasses is just syntactic sugar for what we see below, because because when we are creating the employee struct, if you look back to when we are declaring the employee struct, you will see that we are actually embedding the person struct into it. When embedding the person struct into it, we are also embedding the properties that the person struct has, which is name and wear glasses. And going back to the bottom right screenshot with function main, you will see that we are using a syntactic sugar which is equivalent to doing emp.person.wearglasses. In our case, we are doing emp.wearglasses is equal to false because those two are the same. And the other two assignments are just basic assignment, which is emp.name and emp.department. This also is same to emp.person.name and emp.person.name and emp.animal.name, where we are assigning John Doe and Tiger. And at the end, we are printing this employee object with all the properties in it. And when we are printing the employee object, this function println from the form package knows that it should call to the string methods in our case here. Here we have an example of struct attributes. We have a cat struct and it contains a property file type string. This file's property has a struct or a struct field attribute, which is denoted by the backticks JSON:"file." What this means is whenever we are doing JSON unmarshalling or marshalling, in the JSON object, it will look for that file key and associate it to the property file in the cat struct. Just below that cat struct, we can see an example of how channels are used in Go. We have a getCat function which loads a cat. In the parameter of this function, we have a tube parameter, which is just a read-only channel of type string. In the body of getCat, we are doing a simple HTTP request to aws.random.cat/meow. We are then reading the body of that request in a response variable, and after which we are using that response variable to unmarshal the value in our cat object, which has been declared earlier. And then we are passing the property file of the cat object into the tube channel, which we received as a parameter in the function. On the right hand side of your screen, we then have our entry point func main, in which we have a group declarations of some variable cats, and you would see a new library being used here, which is sync. The sync library exposes some methods which are helpful when working with channels and with Go routines. On the next line, we have a for loop that creates four Go routine of getCat, which is denoted by the Go keyword. Using the Go keyword and then name of the function of the word getCat with its parameter tube, we are firing 4 Go routines. But we also need to wait for it to complete. So we create a wait group, and that wait group, we add 1 every time we are firing those Go routine, so we are able to track them. Afterward, we are creating a single thread or a single Go routine to read all the values from the tube or from the channel tube that we created earlier. We can loop over that channel using the range keyword in a for loop, and we append the values that we received through that tube channel into the cat's slice of string. And then each time we do that, we know that we have done with that group or that Go routine. We call the done method from wait group, which subtracts 1 from the wait group. And at the end, we wait for all the threads to complete using wg.wait, the wait method. And one thing that is very important is we need to close our channel tube. And after which, we print all the cats we received in the slice of string. Thank you. That will be all from me.
So as you can see, Jules has shown, the syntax itself is very simple. You can read it without much prior knowledge of the language. And now I will try to show more of the language and the code, how we can use it for HTTP services, okay, with some examples. Here is a quick description of the basics that we expect from a microservice. Usually, we again start with func main. We are creating a route /hello, and we are just going to say hello world to it. The code itself is quite verbose in and of its own. So there's no much to explain here. And below, we are also creating other kind of handlers. I don't need to declare an anonymous function. I can use already existing functions that have been implemented elsewhere, or even loaded from a library. So Go can do hello world easily. You can also have GET request. In this particular example, we will try to receive all values passed as query string, and we will send it back as a JSON using a JSON encoder. These are features that exist already in the language. Okay, so back to our main. We also have a post handler. We will try to see how we can read contents of a post request, the body. We will try to unmarshal it using JSON. And Go also has a built-in templating engine. We will try to see that with the template handler. So onwards to the post handler. Essentially, we will try to start this. Let's see .0. Okay. So actually, let's do a Go build. I will show you how you can compile your code. For example, you have this one, the basics. I can just put all my code here in the same directory. I'm not using particularly complicated packages because this is a very simple, straightforward example. To begin with, so once we are in the directory, we'll try to do a Go build. Let's see what it has produced. It has produced this executable program that we can run like this. So it is running. I have not put any output, so it will just say, it will just wait here until you can execute it. Let's try our different routes. So for the first example, we are going to send our request. So dev on. We are going to do a send a request. You can see all the values that have been sent in the HTTP request are sent back, and it's quite fast too. It took like 7 milliseconds. So let's go to and then once it so it's fairly simple. Now for the post request, it is outputting hello DevCon 2020, but what is actually in it? First, we want to define what kind of message we want to be receiving. We are expecting a message to contain a field name. Okay, so again, I read everything I have from my body. It's fairly easy. Go and tells you to do explicit error handling. Don't just let errors go by. So you can get an error from reading the body. Maybe the encoding is not correct. Maybe it is missing. Maybe there's a network error of some sort. You want to handle the error directly here, and probably on a production environment, you will output. You will use a proper logging function at this particular point. An error here is not the same as an error below, so you handle it where it happens. In other languages, you might have a big try and everything goes in the body and you have a single catch. So when an error occurs, you don't know exactly where it is. Of course, you can use different try catches, but Go recommends that you handle the error as soon as you can. So I'm unmarshalling. Unmarshalling is very straightforward in Go. And I am going to output a header status, okay? Of course, Go does it for you. This happens by default if you do not specify it, but we want to be explicit here. And we can write just a stream of bytes, just like we have received. And now for templating, let's open this link in the browser. See what happens. So you have this nice HTML that has been rendered for us. Okay. How do we go about doing this? In the template.go, this is the function. At the very beginning, I'm declaring my templates. Using must means if the template cannot be compiled, the application will fail at the very start. It will not fail during execution. It will fail during initialization. And our template here is on disk. There are ways you can embed the template in your binary, but we are keeping things simple here. The templating language is very simple. I'm just dealing with planets. A planet has a name and a photo. Again, Go being a type language, wants you to be very explicit about what you're doing. I have a planet which is a slice of planets. I have defined these values already. And then I'm just telling the template, okay, please execute the template on the output stream. The output stream itself is the HTTP response writer. And I'm going to pass you the values planets. And here, as you can see, I am doing a loop on planets, outputting the name and the photo. Fairly simple. No need for external libraries here, and it just works like we just saw. That will be for the basics. Go can do simple HTTP, can do also templating. Now let's try to do something that we might encounter more in we are trying to make a REST endpoint. Our endpoint will be dealing with two resources, articles and authors. This part is called a JSON tag. I am going to specify what will be the name of the fields in the JSON response when I will be encoding it as JSON. And this is for generating fake data on this article. We will be seeding our data, our in-memory articles using a fake library. So init always executes before main. So I am just going to be seeding it with 10 articles. Okay. And rather than defining separate handlers, I have defined a service. Listen and serve here, as you can see, it will accept a handler. Okay. What kind of handler? A handler is anything that has a serve HTTP function with this particular signature. So as with any REST system, we will be switching on the method. Based on the method, we will be calling a different handler. The handlers themselves have been defined in the service as methods of the service. So even if you do not learn, you do not know Go, you can see that we are getting a request, and we want to see, based on the method of the request, what we will be doing. So if the method is get, that's very verbose, post, put, delete, and if it is anything else that we do not want to handle, we just return with a status method not allowed, which is how we do it in the REST paradigm. But if it is a get, we want to see if it ends with an ID. If it ends with an ID, then it will be a get. If it does not, then it will be a list. The implementation is fairly simple itself. Rather than outputting it directly here, we have used a response object, which will be doing the work for us. Response, when we do send, it will already say application JSON. We will be encoding it directly to the output stream. If we normally, the status will be okay, and we will be writing our status here. If no data passed, we send an empty JSON, and else we will be actually encoding the data. Okay, so back to our service. By doing a list, we are just sending data, the slice directly. It will do the encoding for us. If we are trying to do a get, we loop in the articles. Normally that would be a database query. Go has ample support for all SQL databases, and also cloud services, and also even Mongo databases and other NoSQL databases. But here, for simplicity, we are using in a memory slice. We're able to loop in it, and if we are not able to find it, we will just say status not found. And Go also allows us for the put, we will be adding the article here in our slice by marshalling, and then we just put our article, we get the ID, and then we just send back the article that we have to replace it. Okay. And then for creation also, it's not a big deal. Here we are actually replacing for the put. Okay, for the put we are replacing. For the delete, we will be removing it. To remove, we use a simple trick here. We are just sending the article to the end of the slice, and then we are trimming the slice by 1. Create is similar to put, just that we are appending, so we don't have to look for the article. Now, how do we go about testing it? Let's go back to our terminal. So Go build. It is, even for compilation, it is rather fast, so that's an advantage when you're developing. So let's try to get our articles. Here it is. Some great random data for us. And all the data that has been generated, let's try to get this one. Okay. works as expected. Everything working just fine. And it is rather fast also. So we want to try to put a new thing here, replace it. We're able to change what needs to be. And if you want to delete, that's okay as well. Okay. And even for the post, let's try to create a new article. Okay, it has been able to actually create it. So it is very easy to do a simple REST service, which goes on to illustrate how good Go is for microservices. So the speed of it. And for our final demonstration, I will be showing how to, we will be using servers, a streaming request. How does it work? Let's see the demo first, and then we will come back to the code. Again, go build. Okay. So it is listening on 8080. Let's go to our requests. Yeah. Okay. So this is a simple service. We have the quotes handler. The quotes handler is actually looking for a message, and we have said that the message, we will be actually looking for two backend services. A backend service that will a backend service that will be looking for a name. Okay, it returns a surname and a name. It is making a request over HTTP, and for the quote also, it is going to be making another request over HTTP. But the big advantage here is that we can do both these requests simultaneously. We are not going to be waiting for the name first and then the content. We will be letting them work in parallel. And once we get both, we can actually return a message. Okay. So we are going to get our message. And once we get our message, we're going to encode it using JSON, so we can see this works. Okay. Here there is an issue with our name backend service. It is returning anonymous all the time, but the application is still running. We are not facing any downtime because we have been able to deal with the errors and all. And now about how do we turn this into a stream? So what kind of stream are we talking about? Sorry, let's see. That's not it. That's it. So we are going to be having this here. Let's try. Here, there is some concurrency that is at play, which is why I'm going to try to show you on two different browsers. We are fetching data on the internet, and we want to keep fetching data at an interval. How do we go around doing that? We have defined a very simple stream object. No external libraries used. On the stream, we will have listeners. A listener will have an ID and will be able to accept messages over a channel. And we will be using a mutex just to protect this map to ensure that it works concurrently, read and write. So whenever we are going to start the stream, it will get a message. get a message, initially it was not concurrent. We have just made it concurrent by using the Go keyword here. We just broadcast everything, and then we sleep for 3 seconds. How do we broadcast? Broadcasting is simple. We loop once we get them, we get some content. We loop over all listeners, and then we just put the message in the channel. And whenever anyone wants to tune in our channel, we lock the mutex on the map. We add a new person, and then we return the ID. Okay. And again, similar for tuning out, we just delete the ID from the map. But the interesting thing here is the stream handler. The stream handler will work whenever a new person comes to the website. There will be the stream handler. The stream handler, we will try to flush at interval different content. We're actually using an event stream, which is part of the HTTP protocol. Whenever you are sending data, streaming data from the server, but the client does not need to send data back, this is a very good protocol to use. You do not always need to use WebSocket for this kind of purpose. So first, we are going to tune in, and then I am using the differ keyword here. This will execute just before the function exits. We want to ensure that we are not broadcasting to people who have already left. So I am tuning out whenever this function exists for whatever reason. Okay, so I am going to take, as you can see, message here is of the type channel. It is a receiver channel. We will be receiving message from it, and once we get message, we just print it back to the client. So what are we dealing with here? If you go on the network, let's reload the page. You can see it is fairly well synchronized. We're dealing with an event stream. Okay, Firefox is not showing it, but this is one of the nice things we can do with Go, to easily take a simple function and add concurrency to it. Get code here, for example, is a synchronous function. It gets data from an external service and then returns it, no concurrency. Get name, also same thing. It gets data from an external service and it returns a value, no concurrency. But when we do a get message, we add some concurrency to it here, and we deal with the concurrency. Same goes for string. Stream, it does not know that whether or not get message is concurrent or not. It does not need to know, but it is able to add a wrapper over it and just get the message, assume that the message will always return because we are dealing with errors externally, and then we are able to broadcast quite easily. So that's one of the major advantages of Golang, where you can easily consume external data and add concurrency to your application without overthinking it. So that will be all the time we have for demos today. So that's it for the demos. Before finishing, I'll just give a list of resources that will help you start with Go. We have the to.golang.org, which is very easy. It can take like 15 minutes for you to just master the syntax of the language, try to do some things of it. And once you're able to do that, you have effective Go, where you can write Go correctly. If you need a library for Go, you don't know where to find it, we have Awesome Go. There's also Go by example. If you want to do a particular task, but you're too lazy to write the code yourself, or you're not sure how to do it. And you have amazing Golang books also. And there's a podcast called Go Time, where you can hear about people who are leading in the community. Of course, you have GoFirst.mu, which is our user group in Mauritius. You're welcome to join us. So thank you very much for watching, and please don't forget to give feedback. That was it, Jules and I.
Sure. Thank you very much. We hope you enjoyed our presentation about Go.
Okay, so yes, Yusuf and we have with us Jules. We have some questions from the audience. Rengen asked the 2 questions. So can I start?
Yes, please.
Yes. So the first question is slice similar to a list in concepts / semantics?
Well, it depends. A slice can accommodate data of the same type. You can increase the size of the slice. You can reduce it. So in that case, yes, it is effectively a list. But that's to go in more the technicalities of the language, which you don't need to know if you just want to develop microservices. But if you want to go further, a slice actually is a pointer to a series of contiguous memory locations. So that it actually points to where the data is actually stored. So in that sense, it is a list. But there are other kinds of lists in Go, which you can use for specific purposes. You have weak lists if you want to keep weak references to your data, for example, for caching purposes and all. You can also have, you have seen maps. With a map, we are using mutex, but you have specialized maps that come with built-in concurrency handling. But for our simple purposes, it is not necessary to worry too much about it in the beginning.
Okay. So, yeah. So we have a second question from Rengen. Are the JSON tags type annotations?
Can you please repeat? I didn't catch it.
Okay. Are the JSON tags type annotations?
There are annotations, but I'm not sure exactly what you mean by type annotations. It just provides metadata. Golang has a built-in library. I'll try to go to one of the JSON tags that we had. Yeah, we have JSON tags here. These tags.
Wait, each needs to change the scene for you to show that. Wait.
Just give me 2 seconds. That's happening, and it's live now.
Yeah. As you can see, this is a struct. Go allows you to define metadata on a struct using just this. Okay, anything you write here, you can retrieve it later. But there is a library in Go which follows a convention. The convention is this will be a name, this will be a value, and between name value pairs, there will be a space. So you can effectively retrieve this metadata quite easily. If I'm looking at the field ID, I want to retrieve the metadata for the value JSON, I will get the ID value. But another library is using Faker, for example. This is a third-party library that I'm using. The convention is that they wanted to use Faker with their own rules here. But we use JSON. This is fairly common because JSON marshalling is built in the language. There's also XML marshalling where you can define use the tags for XML. But there's nothing that prevents you, if you want to do advanced Go, to define your own tags for your own metadata. So that's about it. It is metadata about the fields in a struct.
Okay, maybe you should change this thing again.
Yeah.
Yes, we are back on the speakers and host area. Yusuf and Jules, thank you very much for the presentation. And I think any further questions or comments from people who are watching can continue on Facebook, can continue on Twitter. So I'm sure you guys will answer.
Yes.
So once again, Jules, Yusuf, thank you very much. Grish, I leave it to you for closing remarks.
Yeah, I think we have again, and the next session will be presented by Jules. So yeah, let's take a short break and get back. We have another question, but yeah, I think we can take that on social media, right?
Yes. Okay, guys, we will have a short breaks of maybe 5 minutes or so, and then we will be back with Jules for his next presentation. Hey guys, we are back online on Kryptone. There is me, Girish, and Jules. Girish, over to you now.
Yes. Yes, we still have Jules with us, who is going to give us a talk on Golang in the clouds, serverless. So yeah, maybe I'll hand it on to Jules. He will get a short presentation on himself and then start.
Okay, so I'll do my presentation just right after this slide here. So welcome to my session about Go in the cloud. In this session, I'll demonstrate how to deploy Go application in the cloud. In short, we'll speak about serverless Go apps. So let's get started. So about me, my name is Joel Michael, also known as Mike. You can find me online as Michael Go or Michael, if I was lucky enough to reserve that nickname. I'm a senior web developer at Bocase. We are always recruiting if you're interested. So just a small pitch about Bocase is it is an offshore IT service center, over 150 employees globally. In Mauritius, we are located in Eben. It's a great and fun environment to work. So if you love working with new technologies, look no further. Programming has always been my passion. It's been for a very long time now. I enjoy discovering new programming languages, tips, tricks, techniques, and libraries. I've switched to Linux as my daily driver since 5 years, and I never looked back. I'm not much of a social networking person, so you won't find me on social networking site, except if you're on Reddit or LinkedIn. And last but not least of all, I enjoy watching shows like Rick and Morty in my spare times. So for those who did not attend our previous session about Go, Zero to Hero, here's a quick sum up about Go for you. Go is an open source programming language that makes it easy to build simple, reliable, and efficient software. As can be seen, the syntax is very minimal and friendly to the eye. Go code is organized in packages. For fellow programmers, think of it as libraries or modules. In our instance, we are in the main package. To import any of those packages, we obviously use the import syntax, followed by the package name or path. Every executable needs an entry point, aka a starting point. And in Go, it is denoted by the function main. We then use the print with new line function in the FMT package to say hello developers in Mandarin. Please note the support for UTF-8. I've been using Go for the past 3 years, and it easily made it to the top of my favorite programming languages. First off, there are many reasons why I love Go. These are just some of them on top of my head. Go excels in being simple and easy to understand. With a very small language specs document, Go strives to be easy to both read and write. Go is a compiled language. Unsurprisingly, compiled languages are known for their speed, as they are converted directly into machine-level code that can be read directly by the computer. In addition to its quickness as a compiled language, the Go compiler offers additional benefits like being able to check for errors, easier deployment, and ability to optimize your code for efficiency. Another unique feature of Go is the ability to cross-compile your application to run on the different machines with different architectures. Deploying Go applications to production servers or local machines is a breeze. All it requires is moving the final executable file to the targeted location. Sometimes I don't mind taking out the trash, but for my own developer happiness and sanity, I prefer having an automated garbage collection take care of that for me. Go was built by Google, who's got magnitude bigger worries than we do when it comes to serving millions of requests. As such, Go was designed with scalability in mind, and Go has many built-in features designed to handle concurrency, most notably Go routines and channels. So what is a cloud? We're speaking about deploying Go to the cloud. The cloud refers to servers that are accessed over the internet and the software and databases that run on those servers. By using cloud computing, users and companies don't have to manage physical servers themselves or run software applications on their own machines. How is it possible? Well, cloud computing is possible because of a technology called virtualization. I'm sure some of you have heard about it. So virtualization allows for the creation of a simulated digital-only virtual computer that behaves as if it were a physical computer with its own hardware. Now, let's dive into what is serverless, because it has been a buzzword for a while. The underlying purpose of this presentation was to push myself into understanding all the hype behind this buzzword. After extensive research, I have concluded that serverless can be defined as such. In serverless, you do not have to manually provision and manage your servers on the cloud. Traditionally, you would select the spec of your servers and handle all the nitty-gritty work of managing those servers. In serverless, you care more about your application's business logic than how to manage your servers holding your application. Serverless apps scale seamlessly. The provider of your serverless solution will take care of creating as much instance or beefing up your servers as needed to handle the workload. This flexibility ensures that there is no downtime in your service due to servers clogging up under heavy load. You no more need to have to future-proof your servers in case traffic increases unexpectedly. Unless you created a killer app, your application most of the time won't be serving a constant flow of traffic. This is true for small to medium-sized companies. Even if traffic drops to near zero, under the traditional architecture, you'd still pay a fixed charge based on your server's spec. In serverless, you only pay for the resources your app uses. Your app will even automatically scale down to zero when it has no work to do. We'll now go through some of the serverless platforms that you can use to implement or to deploy your serverless app. These platforms provide platform as a service. Each of them provide a series of fully managed services to make hosting your serverless application with them a delight. So some of the popular one, as we all know, is AWS. And we have Google Cloud Platform and Microsoft Azure. Going into the differences between each of these platforms is outside the scope of this presentation, but you're free to investigate and find what suits you best. Since I'm more comfortable with GCP or Google Cloud Platform, I'll choose it in the meantime. Google Cloud Platform, offered by Google, is a suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end user products, such as Google Search, Gmail, file storage, and YouTube. That suite consists of more than 90 standalone services, or so-called products. That's a lot. Obviously, we won't be able to go over all of these products, but we'll focus on only those that will help us deploy our Go app in serverless fashion. The three products that interest us are Cloud Functions, Cloud App Engine, and Cloud Run. As we are going through each of these products, you will see that some of the products from GCP will help us implement powerful solution among all of these products. So let's start with Cloud Functions. Google Cloud Function is a lightweight compute solution for developers. Allow them to create a single-purpose standalone function that responds to cloud events without the need to manage a server or runtime environment. It is good to know that there are two types of Cloud Functions. One type is triggered by HTTP requests, and the other type is triggered by events in the background like PubSub event or GCP product event. For the purpose of this presentation, we'll focus on creating HTTP triggered Cloud Function. Before we begin using Cloud Function, we need to ensure that we have a Google account and that we are logged in the GCP console. After we are logged in the GCP console, we need to ensure that we create a cloud project, a GCP project. And then the next few things we need to do is to ensure that a billing account is associated to our Google Cloud project, and that we have enabled the Cloud Functions and Cloud Build APIs. Let me just give me a second that I'll try to showcase it right now. I'll move out of full screen here. Voila. So this is the main site for GCP at cloud.google.com. I'll zoom in a bit for you to be able to see. Every information you'll need, documentation, support, and why you should use GCP is found at this address. Since I'm already logged in, making sure that I'm logged into the correct account, voila, I'll head to the console, to the GCP console or Google Cloud console by clicking on the right-hand side, the top right-hand side of my screen. For the purpose of this presentation, I've already created a project. But you can also create a project very easily. When you go for the first time on the Google Cloud Platform, it will ask you to create a project or to select a project if you have already created one. If you have a Firebase account and have already created a project there, under the hood, a Firebase project is no more than a Google Cloud Platform project. In my case, my project name is called Go in the Cloud. Again, I will zoom it just a little bit so all of you can see. Voila. So to create a project, you just click on the drop-down select box, which you find up there, where for me it says Go in the Cloud, which is right next to the logo, Google Cloud Platform. And in the new pop-in screen, you select New Project. This will walk you through the different steps for you to create a project, which is basically select a name for your project and where you want your project to be located, the region of your project. After you've created your project, you will select your project from that same screen here, or it will be selected by default if you didn't have a project before. And an important aspect or an important information about your project that you should know is every project you create on GCP has an ID, and this project ID will be used, will be required when you're working with the G Cloud or Google Cloud SDK. In my case, as you can see with the check mark, my project has already been selected. Next step that I spoke to you about is it is important to associate a billing account to your project. This can easily be done by clicking on the billing product found in the left tab. When you create a project for the first time on Google Cloud Platform, you might be worried that expenses or heavy expenses will be done, but you don't have to worry about it because you can freely test out Google Cloud Platform through a trial. The first time you would register on the Google Cloud Platform, you'll have a free trial. This free trial entitles you to $300, as you can see here, of trial credit, which you can use to trial the project and will last for over a year. So you don't have to worry of being billed while testing out GCP or Google Cloud Platform. As you can see here, I've already associated a billing account to my project. So we can move forward on on the different products and on the interface of the Google Cloud Platform. So as you can see, I've already pinned some of the various products that we will be using or we will be discussing throughout my session or throughout this presentation. First off, we spoke about Cloud Functions. We also mentioned about Cloud App Engine and Cloud Run. Those are the three main products we'll focus on. But as we are deploying our Go application, some other products are being used in the background as Cloud Build, Container Registry, Storage, and sure, we are using some networking and logging. To keep this presentation as short as possible, we'll not focus on Firestore, but Firestore is a storage solution from GCP. It's the same as Firebase Firestore for those of you who are familiar with Firebase products. So Cloud Functions. How do we create a Cloud Function? There are several ways to do it. One of it being you can use the web interface provided to you, what we are looking right now, to create that function. But for us, what we'll do or how we're going to proceed through it is through the G Cloud SDK. The G Cloud SDK is a command line tool which allows you to interact with your GCP account and with the various project apps found in your GCP account. So I'll now head on to my VS Code. Here we have a very simple Go app, similar to our Hello World app. But this is the HTTP version of the Hello World app. As you can see, we are right now in the package Hello World. We have some few imports, and one of those imports is from the Net Standard library and the HTTP library found in the Net Standard library. We define a simple handler function called Hello HTTP. This Hello HTTP, in the context of a GCP function, is our entry point, which will allow us to handle any HTTP request coming to our Cloud Function. In this case, we will only send back a Hello World and a Cloud Function. So let's see how can we deploy this Cloud Function. So to deploy a cloud function is as easy as one command line that you need to enter. So I'll just copy it and then explain it as we go through it. Here we go. So first of all, we are using the G-Cloud SDK. If you haven't already installed it, I would advise you to do it, and then you'll have to go through a init phase with it, in which you specify which project you want to use, or if you want to create a project. You can create a project, as we've seen, through the web interface, or you can do it from the G-Cloud SDK. Again, we're specifying that we want to use the functions product, after which we specify what actions we want to use for the function, so we are deploying it. We specify the service name, which is here, hello HTTP. And we specify also the runtime, the Go runtime we want to use. In our case, that will be the Go version we want to use. In this case, we'll be using Go 1.13. As discussed earlier, there are two types of cloud function: HTTP cloud functions and background cloud functions. In our case, our cloud function will be triggered by HTTP and will allow public access to our cloud function through the allow unauthenticated. Let's deploy these cloud functions. What is happening in the background is G-Cloud SDK is communicating with Google Cloud Platform through an API and sending our source code, which is found in the Go Cloud directory, to a storage in GCP. And after which, another task is being triggered to deploy our cloud functions. This may take up to 2 minutes, so we'll wait for it to complete. As it is working its way through, depending on your network connection, every product that you use on Google Cloud Platform has internal integration for monitoring and logging. As we saw, we have another GCP product called Logging, and this GCP product called Logging has support for Stackdriver, meaning that you can view logs from all of your projects in a single place, or you can scrub through your logs to see if anything has gone wrong. For instance, while your cloud function are executing, you can scrub through your logs to see if there are any errors, runtime errors, or if there was an issue during deployment. Just waiting for it to finish uploading. Here we go. And now it has done uploading. Just move that slightly above so that you can see what has happened. So we have a build ID. It has already provisioned the servers with enough memory for our cloud function. The entry point is hello HTTP. And this cloud function has been deployed to the Asia Northeast 2 region. As you can see, this is a default that I've set in my Google Cloud Platform project. The runtime, as we specified in our command line argument, is Go 113, and we have a nice status active on it. We now head on to our browser to confirm that it has indeed been properly deployed. We'll refresh the web interface for the cloud functions. Connection is slightly slow, but as you can see, our cloud function has been deployed. You can see all the information that we saw in the console displayed right here. If we click on our function, we'll get more information about statistics of the function, how it has been accessed, how many times has it been been invoked, and when was the last time it was deployed. We can even confirm the trigger URL to test our cloud functions. And this is a front-facing URL that the public or the other users will be using. So if we click on it, we should see our nice message, "Hello world, I'm a cloud function." So here, this is how easy it is to deploy a cloud function. So a cloud function, the unit of work for a cloud function is a function, as you've seen. We've just deployed a function. This is very fine-grained. And probably you're thinking to yourself, well, deploying a cloud function is quite hard. I mean, if I already has a project and I have to split it into several functions and then deploying each part of it, this can be tedious. This can be very tedious over the long run. So let's see what other serverless solution we have from GCP. So like I said, what if functions are too fine-grained and you want to deploy a whole app or several microservices? This is when Cloud App Engine comes into play. It is a highly scalable. It allows you to build highly scalable application on a fully managed serverless platform. And App Engine has two environments. We have the standard and we have the flexible environment. As good measure, I always use standard since it supports the latest Go runtime. And it allows my Go services to scale down to 0. The App Engine's standard environment makes it easy to build and deploy an application that runs reliably under heavy load and with large amounts of data. Deploying our Go app on App Engine is very easy. We just need to use the gcloud app deploy command. Again, we'll head back to our editor. This time I will check out in the App Engine branch. Let's take a look at what we have here. We have a simple HTTP server. Same as before, we have our package main that we've discussed in previous slides. And this package main creates a small HTTP server. We have some few logging function. And as we had for our cloud function, we have an entry point for our HTTP request, which is the handler function. The handler functions will print "Hello world, I'm running from App Engine." And this HTTP server will run on a port that is defined by our environment variable port, which is provided to us by the GCP product that we are using. In our case, that will be Cloud App Engine. But if we don't have any port coming from our environment variable, we'll default to port 8080. Then we'll listen and serve on that port. If there's any error, we'll fetch a log. All the logging message will go to the GCP logging product. Another thing that you might notice here is the presence of an app.yml file. The app.yml file defines different configuration settings for Cloud App Engine. In our case, we'll only define a configuration, which is we'll use the Go 1.14 runtime. So let's deploy this our Go app on App Engine. Again, in the background, what is happening is our source code is being sent to GCP. It's telling us if we want to deploy that service. I'm just gonna say yes. Here it is much more prevalent or much more explicit that we are uploading files to the Google Cloud Storage. It is updating our service. In my case, that would be the default service since I didn't specify a service name. In the meantime, I'll head in my browser to the App Engine web interface so we can confirm successful deployment. In App Engine, you can have several services or microservices. Usually by default, you have one service, which is called default. And for that service or for the various services that you have different versions of those services. In our case, we have a new service that is actually being deployed. Right now, what GCP is doing is setting the traffic split for service default. So all traffic that was routed through the previous version of our default service will be rerouted to the new version of our service. I already had a version of that service running before for testing purposes. And the routing has been done. So if I refresh the Google Cloud Platform web interface, you should see that all traffic has been rerouted to the new version of our default service. Let's now head to our deployed service, which is found at this URL. And as seen, voila, hello world, I'm running from App Engine. This was how easy you can deploy your application with the Cloud App Engine. Let's now say that you have a container and that you want to deploy your container packaging, all the libraries you need, application you need in a serverless architecture. There comes Cloud Run. So Cloud Run is a managed compute platform that enables you to run stateless containers that are invocable via web requests or pub/sub events. The de facto or industry standard for creating containers, as we all know, is Docker. So what we'll do now is use that same Go app you've seen before and deploy it, build it in a container and deploy it to Cloud Run. For that, we'll use two separate commands. The first command is using the cloud build product from GCP. So in the first command, we send our Docker file and source file to Cloud Build to build an image for us and push that image to Google Container Registry, GCR. And the second command that we'll use will create a new Cloud Run service called Hello World and uses the image that we've uploaded to Google Container Registry. So we'll head back to our application in our editor. switch out to our feature run branch. And in that feature run branch, our main.go file hasn't changed. It is similar to what we used for App Engine. But we now have a Docker file. In that Docker file, I'm doing a multi-stage build. Our first stage, from line 1 to 9, uses our base image Golang 1.15.1 Alpine. This stage, I've named it the builder stage, because the sole responsibility of this stage is to build a single executable file using the Go build tool. The environment variable cgo enable equal to 0 makes sure that the file that we are building is fully static, and we are specifying our targeted operating system to be Linux. So our binary hello will be built for Linux. On line 12 to 18, we are packaging this binary in an image, and that image is a scratch image, which will contain no other dependencies, files, even a package manager. Nothing will be present in here, just our binary, which we are copying from our multi-stage builder. So let's see how we can deploy this image or container to GCP. First command that we will run is to submit our Docker file and the source file to Cloud Build. Cloud Build will build the Docker file for us and push the Docker image that has been created to Google Container Registry. As we can see, we are submitting our Docker file with the tag gcr.io. The next few lines are our project ID, Arabic -form a numeric value. And afterward, we are specifying our container name. In our case, it will be hello world. A tarball, a temporary tarball, is created with all the 4 files that we have in our Go Cloud. And this tarball is submitted to Google Cloud Build. And Google Cloud Build will take care of building our container for us. As you can see, it is stepping through our Docker file, pulling the base image, going step by step through our Docker file. And right now it is at step 6 where it was building our Go app. This has already been done. It just pushed it to Google Container Registry. And the next few lines, we saw that it has been successfully deployed on Cloud Run. Oh, sorry, the next few lines show that it has successfully been stored in the Google Container Registry. Now we'll deploy it on Cloud Run. So same as for our functions and our App Engine, we need to specify a service name. In our case, that will be Hello World. We specify the image we'll be using, which we've just stored on the Google Container Registry at this URL. And we are also specifying that we want our platform to be fully managed using the argument platform managed, and that we want public requests, and we want that application to be public facing. We don't want any authentication on it. Let's now deploy it. So as you can see, it is deploying a new service. It will create the revision, route the traffic, and setting the proper identity, and permissions. And voila, our service Hello World has been successfully deployed. And this is the revision number for, or the revision tag for our service Hello World. And we can find this Cloud Run service we've just deployed at the following URL. But I'll show you through the web interface how you can access. Going back to the web interface, we'll go to our Cloud Run. And as you can see, the Hello World service has been successfully deployed to the Asia Northeast 2 region. This is set by default in my project, but you can select any region you want to deploy to. If we click on the Hello World service, we'll get more details, metrics, revision logs about our service and how much traffic it has handled recently. So as we've seen in the console, the revision that has been deployed is the Hello World 0001 with revision, which has just been deployed 1 minute ago. And to access our service, we can use the following URL. And here it is. Hello world, I'm from Cloud Run. And this was how easy it can be to deploy any application or even your Go app to Cloud Run. As you saw, in many of those circumstances, we have been using Cloud Build. Cloud Build allows you to automate your builds and deployment and can deploy to Cloud Functions, Cloud App Engine, and Cloud Run. I won't bore you with the pricing, but what you should know is the Google Cloud Pricing Calculator allows you to calculate the total estimated cost of your services running across different GCP products. Each GCP product has its own pricing page and documentation. I cannot stress enough how great their documentation is, so I highly encourage all of you to dive into them to learn about their products. If you want a quick overview about GCP and the range of products, you can also head to the Google Cloud Platform YouTube channel. These videos have helped me understand the power and flexibility of GCP products and how I can leverage my Go application using them. Thank you all for attending my session. Hope you had a great time exploring serverless with Go on GCP. Hello.
Hello.
Yes. Ish, are you
Jules?
back?
Yes, I got disconnected, guys. Can you add Jules quickly so that he does the ending?
Jules, are you here?
Yes, I am here. Can you hear me?
Jules, yes, we can hear you. Sorry, the disconnection was on my side. Can you start your screen sharing again, please?
Okay, sure.
Webcam.
Is that good? Is that good now?
No, we cannot see your screen.
Here we go.
No, we have your webcam right now.
Oh, you want to see my screen? Sorry about that.
Yes, your screen. You are still, thanking people. We'd let you finish on that slide, and then we can take it from there.
Okay, sure. Here you go. Can you see it?
Yeah, yes, because it finished right before you started thanking people. So do the last final slide about thanking people, and then we take it from there.
Okay, so thank you for attending my presentation about Go in the cloud. I hope that will give you an idea on how you can deploy Go application easily to the cloud. You can do it the traditional way where you have a single binary and send it to a server through SSH or something like that, or you can simply do an automated deployment using GCP products or AWS or even Microsoft Azure.
Thank you very much, Jules. We are back. Girish, myself, and Jules. Jules, you can cancel the screen sharing now, and we get your camera back. So that was a nice presentation. Even I got to learn a couple of things about the Google Cloud, about GCP, and I was trying to compare and contrast in my head GCP versus AWS. These days, I do not have a lot of money to spend, so even before spending on GCP, I think twice, and I go for smaller platforms like DigitalOcean, Linode, and it's there. But that's for me. Looking at the live stream, let me tell you that, in fact, there was a question by Sandeep. He wanted to compare GCP versus AWS, exact same thing that I was doing in my head. So,
Okay,
would
so
you like to say something like that?
I guess you are the expert on AWS. I'm more of the
Well,
GCP guy.
not so, but maybe when you watch the videos about people telling things about GCP, is there anything in particular? Because I showed in one of your previous slides, you recommended some videos. So is there something particular that you want to say about GCP?
One thing that I want to say about GCP is the cost is very low. Before I was running a Linode server, but I wasn't getting a lot of traffic to my Linode server. So I switched on to GCP because it scales down to 0. So whenever my applications were not being used or my services that I've deployed were not being used, I didn't pay for it. One thing that I like about GCP is the trial that they give you. So when you start using GCP, you get $300 and you get a full year of trial. So you don't have to pay for anything. You can just go through it and trial it. Other things is GCP integrates well with all their different services we have. For instance, I was speaking that there's more than 90 products in GCP, and all those products integrates well together. This is something that I really like. I don't know if AWS does that, but I'm not going to compare because I'm not on that part. But for instance, in my presentation, you saw that I've deployed to Cloud Run. But before deploying to Cloud Run, I had to create a container. And to create that container, I used GCP Cloud Build under the run, which built the container for me and deployed it to another GCP product, which is called Google Container Registry. It's similar to Docker Hub. So
okay,
it deployed
let me just stop you here before you continue.
Yes.
Are you saying that if somebody, let's say Girish right now wants to experiment with GCP and with a trial account of $300, okay, will he be able to do all of these, like to build a container? Okay, nice, Girish.
Yes,
Yeah.
he can go ahead.
I did try it with. Actually, Joki told me about that. I did try it with for container applications like Kubernetes.
Yeah.
It was pretty nice, but I just started like 2 weeks ago, so not much that I can say right now.
Yeah.
But
then
I would actually
okay, Jules, I will let you continue. No, go on.
No, it is just that every GCP product integrates well together. For instance, if you have to do login in the traditional fashion, you'll have to care for a server that will actually take all your log, like Logstash or something like that.
Yes.
But in GCP, you have a specific product called GCP Login, where you have all your metrics, your logs associated to the various services that you have deployed on either in a serverless architecture or in the all manner ways like using Kubernetes and so on. I mean, it is it is a very nice experience. I myself am a newbie at GCP. I've just switched over, but from what I've experienced so far, it is a great experience. And since Go is compiled to a single binary, it makes it even easier to deploy your application on GCP.
Nice. Listening from your experience on GCP, I can tell you that probably we'll see you again for DevFest,
Okay.
where there will be a lot of topics on Google, the Google Developers Group and the various topics. Probably, it will be very nice for you if you can do something more rather than you've done something about Go during DevCon. Probably you can do something which is more focused on the on GCP and how you're taking the full power. So
Okay, sure.
yes, we'll be glad to see you again. And thank you very much. This was your second presentation in a row, although
Yes.
your previous presentation was a shared one. But
Yeah.
thank you for your time. Nice presentation. I do not see any other question, but good things about your presentation. All right, cool. So that would be all for us today in this presentation, Jules and Girish. Let me switch us back to the speaker loop. We're gonna have, to the sponsor loop. We're gonna have a short break before the next presentation, which is scheduled to start at 1200 hours Mauritian time.
Cheers. Bye.
2 seconds. Yeah. C'est-à-dire, let's say 3, 2, 1, and here we go. We are live with Girish, Jovan, our next speaker, and I'm Ish. Girish, it's up to you now.
Okay, so we have with us you get us a talk about monitor elderly people using the ESP32 microcontroller, how you can do it yourself. So it will be mostly a demo, I think. A few words on our speaker. Jovan Fowler is a technology enthusiast. He shouldered various managerial responsibilities in technology-oriented companies. Jovan is also the founder of Generation Plus Limited and co-founder of the Mauritius Maker community. He's a really interesting person. I will now pass on to him to elaborate a bit and then start with the presentation.
Hello, everyone. Good morning. So today I'm going to talk about a device that you can make yourself around a microcontroller. So prior to that, I'm just going to introduce myself. So I'm really a person who likes technology. I've been involved.
Ish. Ish.
Okay. So the agenda today is going to, I will talk a little bit about the Mauritius Maker community, the makerspace, and how we actually are going to assemble that device. The Mauritius Maker community actually was founded during the launch of the first DevCon 6 years ago. And this is our Facebook page. So I would encourage you to join in on that page if you want to build something. So the maker is actually building things. Okay. And there has been a growing interest in the maker movement, and we have reached, since last I checked, like 700 members. We mostly host meetups and free training. Everything is free, actually, around Arduino IDE, microcontrollers, 3D printing, and IoT. So yeah, with respect to this, what I found was that there was no makerspace in Mauritius. So what I decided to do is like to have a mini makerspace here in Generation Plus, which is the company that I founded some years back, and to have some facility that was not easily available or not affordable for people as well. So we've got a makerspace, and we've got tools like 3D printers, oscilloscope, multimeters, crimping tools, and so on. And we also have got like a training space and video projector and whiteboard. So feel free to contact me if you are interested in renting those spaces. I would be glad to help you, and I've done some tutoring of students from university as well in this makerspace to help them really better understand electronics and so on. So now back to the device that I will be demoing will be something built around a microcontroller that will actually be used to monitor if there is activity around old people. So what we know is that they may have some sort of health issues, and when they stop moving, this is when we know that there is something that is wrong. So this device has got a passive infrared sensor, and it monitors constantly movement around it. So it can be placed like in a place where you know that person is going to walk by and trigger that device. So typically it can be used in a kitchen, bathroom, or even a TV room. So there has been in the coding that I've done 2 severity thresholds are set. Like, for example, if that person doesn't move for, let's say, 1 hour continuously, so we'll call that level 1 severity. And the device will send an email to a person and informing that person that there has been no movement for that period of time. And let's now say like severity level 2 is like for 1.5 hours, there has been no movement. So you really need to take action and try to see if there's something wrong with that person or not. So the email is part of the device functionality, and we'll look into that function, how we can integrate it on a simple microcontroller later in this slide. Okay, so the structure we'll be going through is going to be like, we'll talk about the electronic components. It's like Lego blocks that you use to build something. So each electronic component would be having its own functionality. So we'll talk about the different components that we have used and what are their functionality. Then once we've done that, we'll move to the wiring and creating the device itself. How those different electronics connected between themselves. Okay. Then we'll talk about the coding environment. We will be using the Arduino IDE. And because the microcontroller itself is an ESP32, it is not by default present as a board that you can program in the Arduino IDE. So we'll look into how to add this board, which is not natively supported in the IDE. Then we'll move to the code. We'll see about the libraries and the different function that makes this device. So let's start with the main, let's say the main part, which is not actually an electronic device. It is just a board where you are going to put different kind of electronic components on it, and you are going to connect it. So a breadboard, it is called a breadboard. You just plug in components. We're going to see that live afterwards, not now. How you plug in the different components and use those jumper wires that you see here to interconnect them. So the main part of this circuit is the microcontroller. So just to tell you about microcontrollers, there are different kind of microcontrollers. So you've got Arduino microcontrollers, and you've got other microcontrollers as well. What you need to know is that microcontrollers uses mainly two kind of logic voltage. So there's one which is 3.3 volt and others are 5 volts. So the one that we'll be using is the ESP32 module. It has got 5 megabytes of memory on board and has got Wi-Fi inbuilt and Bluetooth as well as wireless connection channels. So microcontrollers by themselves, they need to be connected to other devices like sensors and actuators. By sensors, I mean like something that is going to sense the environment. So let's say, for example, there's a temperature sensor. So a temperature sensor will sense the temperature around it. Actuators are actually things that are going to output things, like switch on the light, or like switch on a relay that is connected to a fan, for example. So those are actuators. So in IoT, Internet of Things, we often refer to those two main components, sensors and actuators. Actuators actuate, sensors, they sense. Okay. On a microcontroller like the ESP32, you can add lots of sensors. It all depends on the communication channel that you will be using. So, for example, your sensor can be like a remote device that is connected to Bluetooth, or it can be physically connected to the microcontroller. So when it is physically connected to the microcontroller, there are protocols that are being used for that. So one very common protocol that we use and that we'll be using with our device is the I2C protocol. So I2C is just a two-wire connection. Okay, so your device is going to communicate with two wires, and you can, in parallel, add additional I2C device. By that I mean that you've got let's say an extension plug, okay, and then you can plug in your TV, you can plug in your game console, and so on the same plug. So it is the same as I2C. So what you need to know in I2C also is that each device will have a unique address, meaning that we are going to address them uniquely by using their address. Okay, so let's move to the next slide now. All right. So most of our microcontrollers, they do not have like an internal clock. They do not know like the time, the current time. So to achieve this, we will be using an external device. It is called an RTC module. So the RTC module that we'll be using is a DS3231. Its working voltage is 5 volt, but do remember that I told you that the microcontroller has got a 3 volt free logic. So we are going to deal with that, how we are going to power this device. I2C is no problem, so we'll connect it to I2C directly onto the chip. So this RTC module has got a backup battery, meaning that if you switch off your device, it's not going to lose its time, okay? It's going to continue to run on this small battery that is integrated here in the holder. So powering off your device does not mean that you will lose time. It will keep on working even if the device is not powered. Then the next sensor, it's a sensor actually, it is a PIR, commonly known as a PIR, passive infrared module, is the device that is going to be used to see if there is movement that has been detected. Okay, so there are actually two settings that you can do with that device. All right, so there is the delay timer, okay, and the sensitivity or the distance with which it will react. So the sensitivity is like, I'm going to be like, I want it to be triggered if I'm, for example, 1 meter from it, but not more than 1 meter from it. So we adjust the sensitivity with this potentiometer here, okay? And the delay timer as well can be adjusted here. So you would see that there is a VCC, the voltage goes in, the power goes in here, and the ground here. And what it is going to output is just a signal. It's going to turn high whenever it detects a movement. So the working voltage is 5 volt. And remember what I said, that the ESP32 is actually 3.3 volt. So we would need to adapt that, and we will see in the wiring in the future slides how this is going to be done. And the connection is not I2C, it is just going to be a GPIO port. So a GPIO port on the microcontroller is a port that you can configure as being an input, of data or as being an output. Okay, in our case, for the PIR, we will be using the GPIO as an input, because when somebody is going to go near that sensor, it is going to tell the microcontroller on a GPIO port that it has detected some movement. So it is an input for the microcontroller. All right. So we'll be using an OLED display as well for displaying information on that screen. Okay, so OLED is organic light emitting diode display, and it uses the I2C protocol. So as you can see here on the drawing, there's VCC always, and there's ground. So this device is powered by 5 volts, and the connection is made I2C protocol. So this little display, it is quite small, and you'll be able to see it afterwards with the camera, has got a resolution of 128 by 64 pixels. So you can even display graphics on it if you want to, but for the purpose of this demo, we'll be only displaying text. Then let's move to the other electronic component. So it's a simple buzzer. Actually, you just power it with 5 volts, and what it does, it just sends a beep, like beep. We'll see how it works. And the connection is a GPIO. So remember, yeah, 3.3 volt, this is 5 volt. How are we going to adapt that? We'll see it afterwards. And here what is important to note is, like, we are going to configure the GPIO as an output port, because it is going to emit something, a voltage on that buzzer for it to sound the beep. Okay. Next slide. So this is the magic. This is where all the magic will be, because you see, we've got a microcontroller which has got a voltage logic of 3.3 volt. Okay, and we've got devices, okay, that are going to be connected to it that would work only on 5 volts. So we will be using a logic level shifter. What this device does is that whenever 3.3 volt is an input, it will send 5 volt on its output. So by 4 devices can be connected either way. So if it gets 5 volts here, it is going to send 3 volts to the microcontroller. If it needs to send 3 volts from the microcontroller and the device that is connected to it requires 5 volts, it is going to shift that logical level here for the device to get the proper voltage. So how this is wired, it's simple. You just give it like an input of 3.3 volt and an input of 5 volts and a common ground to it. And then whatever you put on this side, which is 3.3 volt, will come out as 5 volt. Okay, so it's as simple as that. Simple logic shifter for us to be able to interface devices that works on different voltage. Okay, now we'll go through the wiring of everything. I hope that you will be able to see it clearly. It's not quite a big diagram, but here we go. This shows you how everything is wired. I will push that to a GitHub account so that you can not only have the code, but you will have also the drawings of how everything is wired. And if you want to make your own, yeah, sure, you can make your own and you can modify the code as well. So when we look at this, is our main device. This is our microcontroller. We'll be powering it with a USB cable here. So what I'm going to tell you is like USB from any USB device is going to give you 5 volts. So the 5 volts is going to power this device. But do remember that I've told you that this has got a volt-free logic. So we've got like a circuit around here that is going to transform that 5 volt, okay, and step it down to 3.3 volt for that microcontroller not to fry. So if you power a device, let's say 3.3 volt, you power it with 5 volt, you are going to burn this device. So this step down regulator is going to transform that 5 volts, okay, and give 3.3 volts. But the 5 volts is also going to be present for you to be able to connect your devices. So this is why here, before going to the regulator here, the 3.3 regulator, you can have your 5 volts that is being supplied by the USB. Okay, so you will see we are going to power all our 5 volts devices from this pin that is written 5 volts here. So the first one is going to be the sensor, all right? So the sensor works on 5 volt, if you remember well from the slide. So it is connected here via a wire. Then we are going to connect other devices on 5 volts here. So we go through the logic level shifter here and we connect that device here. So we are supplying 5 volts here. And to power up that converter, that logic shifter. And here we've got a 3.3 volt output. Okay, so the 3.3 volt output is going to power up the device from this side as well. All right. So remember I told you like, okay, our buzzer has got 5 volts, works on 5 volts. So we are going to connect it to one of the output of this logic shifter on the 5 volt side. Okay, so we talked about GPIOs and what are the different outputs. Okay, so this one, for the output of the PIR, we have to go, because it outputs 5 volt, we have to go to the logic shifter here. So it goes on one port of the logic shifter, gets converted to 3.3 volt, and is connected to a GPIO, which is here. All right, so there is that conversion. We've seen for an output, we go the other way around. So GPIO here, connected to logical shifter, goes to the buzzer. This is an output. GPIO configured as an output here. All right, and this is as an input. So you see that it is on the other side. So 5 volts get in here, goes through the logic and the logic shifter and goes to the GPIO here. So you would see that everything is wired that way. And one more thing is like you've seen, like I think I mentioned that it was actually 5 volts. It can be powered from 3.3 volts. So the OLED can be powered from 3.3 volts to 5 volt max. So that is why it doesn't go through the logic shifter. So that was a mistake on my side. I didn't update the slide properly. So yeah, this one gets connected directly to the 3.3 volts rail on that microcontroller. Okay, so is the case for this RTC device. So it goes directly to the 3.3 volts here. Okay, there's no need for a logic shifter. All right, let's move on to the next slide. Okay, Arduino IDE. So we'll be using Arduino IDE, which is quite nice. You can actually, although natively doesn't support many boards, it supports mostly its own Arduino boards. So you can add third-party boards onto this IDE so that you can program them in the same way that you do with Arduino boards. So to do that, it's quite simple. So you go on to the file, the menu of the Arduino IDE, you go in File, Preferences menu, and then you just add this. So this is a repository, a JSON file, where you've got all the details of files and libraries and other references that is going to be downloaded by this IDE. So File, Preferences menu, and you just add this here. Additional boards URL here, you just add it, and then your board will be found in the board list. All right. So libraries required to be installed via the tool Manage Library. So for us to be able to program those different components, we are going to include additional libraries. So to do that, in the Arduino IDE, you go into Manage Library, and then you can add the libraries by searching online what are the libraries that you require. For example, if you type RTC DS3231.h, you are going to see the libraries, and you can choose which library to download. Actually, there are different kind of libraries for the same device as well. So it's up to you to choose the right one. Okay, so let's go through the library that we are currently using in this sketch, in our code. So the RTC DS3231.h is actually for addressing the RTC module, the real-time clock module. Okay. Then we'll be using, for the OLED display, we will be using an Adafruit library, which is the Adafruit SSD 1306.h. So Adafruit, actually what they do is they package a lot of devices in one single library. So yeah, you can download the whole package of library from Adafruit, and this would include also for the OLED. Okay, ESP32 mail client. Actually, this is the mail client that will be sending like emails alert. Okay, NTP client. So we'll be using the network time protocol just to update the real-time clock. It will query a network time protocol server and pull the current time and update the RTC module if needs be. Okay, so network time protocol is interesting due to the fact that it always has like the right time. You query it, you pick up the time, you update your RTC module. Okay, if you can't do that because the system has got a battery on it, if let's say for example when you launch the code, it was not able to connect to the NTP server, or the NTP server was down, okay, it will rely on the RTC itself, the real-time clock of that module. Okay, and then of course, because it is battery backed up, it's going to give you approximately the right time. Okay, So then we'll be using the Wi-Fi UDP.h. So this is like for the NTP client, this is a requirement that you have this module. So the Wi-Fi UDP is a requirement for the NTP client, okay, because the NTP protocol uses UDP to query a server, and you need to have this in. Now we'll look at the code. All right, so the program, as we call it, normally we'll call it a program, or the source code in Arduino is referred to as a sketch. So we'll be referring to sketches when we talk about Arduino IDE. Okay, so the source code is available freely. You can modify, you can do whatever you want with it. Okay, so the source code is available here. Oops, is available on the repository here. So feel free to copy it and modify it as you wish, enhance it, add more functionalities, okay, to it. So I was planning on doing something more about the elderly monitor, was to like a medication reminder. So remember, we've got a small screen, we've got an RTC module. So what can be done with that device additionally than monitoring like movement around an elderly person? You could put a medication reminder, okay? Meaning that that person at 11, for example, should take his medication. So you would program this into this system, into this device, and say, okay, at that time, I do a beep and I put a message that you should take your medication A, for example. All right. And that beep can remain on until, for example, you press on a button and you've acknowledged that you've taken your medication. So feel free to use this code, add those functionality. I haven't had time to do that, but I think it's something that could be very interesting. All right, so what we are going to do now is we'll go through the code and I will show you what module, what function does what. Okay, so now we switch on to the code. So we've already seen the NTP client.h. Those are the libraries that will be loading. So how does Arduino work? Okay, we do a declaration, okay, of our different variables that is going to be used. Then we've got the part that is the setup. And then we've got a loop. So a microcontroller, what it does, it moves from one point here, goes to another, to the last point here, and then step forward again, step backward, I would say, move up back here and continue to execute the same logic in a loop. Okay, this is how microcontrollers they work. All right. So yeah, so what we do here, we do all our declarations here. So okay, so what are we going to define? We're going to define the OLED display. We're going to tell it that we've got a screen width of 128 and a screen height of 64. So this is defined here. And we will define a reset point. So this is kind of important when you are using the OLED and the Adafruit library. All right, there are different kinds of OLED displays. They are not all the same. All right, so this is important that you know what are the specifications of your OLED to define it properly. If you don't do that, then the OLED would not work. All right. So the OLED that I've shown you in the picture uses an OLED reset on pin 4 here. Okay, so then what we do, we call that function, that library, and with the different parameters and the OLED reset, we see it here. All right. Then we have created like a string, okay, which is here a global one because it is defined in the declaration part of our sketch. So we're going to define a global RTC date time. So actually what this variable is going to store, it is going to store at a point in time when we will call a function the current date and time. Okay. So then we are going to define the pin number on which like our passive infrared sensor is connected. So we'll be using GPIO 16 here. All right, so physically on the board, you will see it's written GPIO 16, or if it's not, it depends on the different ESP32. You've got like in the slide that I've shown you, there is like a map which says this pin is GPIO, this pin is, for example, UART, transmit, RX, and so on. So this refers, the number 16 refers to a physical connection on the ESP32. All right. And the buzzer is going to be the actuator, which is a buzzer, is going to be on pin 17. All right, so the first thing that we'll do, we will update the time. We will query the time from the network time protocol server. So in our case, okay, we will be using africa.pool.ntp.org. So what we are saying is that, hey, okay, so all the NTP server, they store time in GMT time, okay? So we're going to tell it, okay, we are querying you, but we are currently GMT +4, okay? So this is what it says, 4 times 3,600 seconds, all right? Then we are going to instantiate SMTP data as SMTP data here. Okay, so we are going, because it needs to connect to an access point, okay, so we are going to give it the credential for that access point. Here in the makerspace, we are going to tell it, okay, this is your SSID and this is the password, all right, and you'll be able to connect to that. So we'll see how we are going to call that function, okay, and then we are going to tell it, hey, come on, RTC module, you use the 2-wire protocol, okay? This is what it says here in the line. Then we are going to set our different parameters into variable. So start hours is going to be when we start the device, okay? And end hours is going to be when we will stop our device. By that I mean the monitoring action starts at 9 a.m. and ends at 23 hours, so 11 p.m. So you can of course lower this. It's up to you. Like for example, you say like that person will be all alone from 9 to 5. Okay. So you would set 9 here and 17 here. So the monitoring process and the sending of notification would only be done during that period of time. Okay, so here we will set our inactivity alert. Okay, so remember I said we are going to have 2 thresholds. So one threshold is going to be set here, inactivity alert. It's just an alert saying, hey, there has been no movement for that specific amount of time. And hey, you need to attend to that side because it has been in the critical inactivity threshold, okay, that is being set here. So for the sake of our demonstration, we are going to set 20 and 40 seconds. So everything here is set in seconds, okay? And then we're going to define the current hour, the current minute, and the current second as an integer, and Boolean as alert sent. So if we've sent an alert, okay, it is going to be in that variable, in that Boolean here, okay? So it's critical sent. So if we've sent an alert, this is going to become true. And if we've sent a critical alert, so it is going to become true. All right. So those are just declaration. And when we start to monitor, meaning in monitoring mode with respect to the time that we've set here, the start hours and the stop hours, so monitoring started will become true. Okay. Unsigned alert millis, critical millis, we'll see about that if we have time. Okay, so remember that once we've finished with the declaration, loading of libraries, declaration, we go through the setup phase. So the setup is, this is what we do here. We are going to tell it that we can receive like debug messages from the serial port. So once you connect a device like this microcontroller, this ESP32, to your computer, it gives you a communication port. Okay, on that communication port, like this device can send messages. Like it's very important for debugging or for initial programming of a project, that you get a feedback of what is happening. And then afterwards, when it goes into release, you can just remove those. So primarily, I use it just to have messages being sent to me. All right. So a delay. So once we've set that, we add a delay, because if we do it too quickly, it's like you won't be able to access this device. We are talking super rapid here. So we begin something, and you have to give it some time before you can access it. Okay. Then you do an RTC beginning. So you start, you say, okay, RTC module, now you begin. So we're going to set now a recipient who is going to receive the email. So I put my Gmail account here. So whenever there's an alert, whether it be critical or non-critical, it's going to send it to my email address. So remember that we've defined the buzzer pin, and we've defined the PIR pin. So we need to tell it now, because I told you, like it is a GPIO, it can be as input or output. This is where we now say, okay, for buzzer pin, you are going to be an output. You are going to output 3.3 volt for the buzzer, okay? And the PIR pin is going to act as an input. So meaning that you will be constantly monitoring that pin to see if there is a 3.3 volt on it, and then we'll have some logic that is going to process it. Okay, so here we'll do the Wi-Fi begin, the SSID, and the password. So we will bring up our Wi-Fi interface here using the SSID and password. Good. So here we go. So I told you we've got an RTC update process. So we are going to update the RTC time, get RTC time. All right. And yeah, as I told you, like we've put the serial monitor, which we've defined above. And we are going to print different messages to be able to show us at what point we are in our program. Okay. Then yeah. So here we will actually initialize our OLED display. Okay. And as we use the I2C bus, we can have in parallel various devices connected to the same I2C bus. So how does the system differentiate from it? It uses an address here to differentiate. Say, I'm addressing you, excuse me. So it will say, I'm addressing that specific device. Okay. So now we've got the loop of things, what we do. So we've got a main function, which is the watchdog. I don't have much time left, so we'll go quickly into it. So we've got the watch daemon here. What it does is, like, it's constantly monitoring. This is the main part of the program. It constantly monitors the PIR. Okay. Now, and then we've got, okay, we are here, PIR read, okay, cool. Let's go into what is important, okay. All right. So this is where we send the email. This function will send the email, all right? So it will be called with the recipient email, the subject, the message, and the message type. Okay, by message type, I mean, is it critical or is it not critical? So we'll see if we can go through that. Okay, so this is what it is using as credential to log in. Okay, just going to move up. Okay, what credential it is using to connect to the SMTP server and then send the mail. All right. All right, the watch daemon. The watch daemon is important, so let's go through it. This is the main logic of the device where alerts are sent. So the first thing is we're going to check if we are within that range of that the device should monitor things or not. So once it is in that range, then it is going to process and send alerts or not. If it is not in that range, it's not going to send alerts, of course. So how are the alerts sent? So it's a simple message, okay? The system has not monitored any movement for more than, okay, the second inactivity alert, okay, and the recipient is going to send the recipient. So this is going to be the subject, sender type here. All right. So this is what is going to be sent via the email. So if it was critical threshold, so this is what it is going to send. So all those are based on conditions here. All right. Then what else? I think as I don't have too much time, we can have like you can send me questions and we can talk about that. But what I would like is that you guys, if you want to experiment with it, modify it and make something that is that can be really used and helpful to elderly people. So I think I'll think I'm almost done. I don't have too much time. Okay, so let's go back to our slide. I don't know if I can do that demo. I'm just going to show you how everything is wired here. So I'm just going to move the camera now to the device itself. I don't know what you are seeing. Let me see if I can have a...
It's good, Jovan. You can see.
It's good. Okay, cool. So this is the device and how it's wired. So you've got, this is the OLED. This is the PIR. This is the level shifter. Okay. So what I'm going to try to do is just for you to, okay, just to show you when it initializes. So you would see on the display, hopefully. Okay, here you go. Can you see that? Can you see the display actually, guys? Okay. All right.
Yes, it's fine. You can
Okay.
move. You can zoom a bit.
Okay. So here you go. There has been some movement that has been detected because I'm just in front of the PIR. So now that a movement has been detected, it normally sends me an alert on the email address that a movement has been detected. And if no movement has been detected for a certain period of time, then this is when I'll receive the alert. So that's about it. I'll end here. I know I have taken all of the time, so I'll leave some for some question and comments. Okay, guys, that should be good for me.
Ish, maybe we can see column one, or split one.
Yes, that's done. That's done. Thank you very much, Jovan. Unfortunately, we were running out of time and we have to end here. So, of course, I already posted a few things on Facebook, on Twitter. Guys, you can reach out to Jovan and ask your questions. And if you would like to experiment further, Jovan is the co-founder of the Mauritius Makers community. They are present on Facebook. Join and maybe in the how do you call that? In the next meetup, you can all have a demo together. Jovan, thank you very much for the
You're most
demo and
welcome.
for the presentation.
Okay,
Yes.
guys, bye.
Yes. Bye bye. And we are
Bye.
moving to our next presentation. Just give me 2 seconds here. So, Girish, can you say 2 words about our next presentation, our next presenter, and then we will take a short break of 4 to 5 minutes.
Okay, yeah, so the next presentation is pre-recorded. So I will just present to you guys the title and the speaker, and after that, we will just play the video. Good?
Yes.
Ish?
Yes, that's fine.
Okay, so it will be on printed circuit boards, design and manufacturing. It will be done by Nathan Margot, who is a maker, member of Cyberstorm MU, and is a student. Yeah, he's a high school student.
All
Okay,
right,
that's all right.
Girish, thank you very much. We are 12:52. In 3 minutes, we should be live with the video. Guys, we're gonna take a short break here. So here we go.
Hello everybody, my name is Nathan Mangar, and in this session we'll be talking about printed circuit board design and manufacturing. So unfortunately I wasn't able to make this session live, so this is pre-recorded. So some information about me. I'm an owner of a blog known as Technolog, which is about open hardware, electronics, printed circuit board design, and some Linux stuff. I'm also a member of the Cyberstorm.mu team. I've been designing printed circuit boards for about 2 years now. I'm a high school student, and I'm also an open hardware enthusiast. Right. So, what are printed circuit boards, first of all? So, printed circuit boards are used to mechanically support and electrically connect electronic components. So, I'm just going to show you a diagram of how this works. So, over here, this is a single-layer PCB. And first of all, you have the substrate here. That's not going to be conductive. And the copper layer, that's where you're going to be doing your circuit and all that. So usually you'd put a pattern for your circuit, and you'd etch it, and you'd have the circuit here. Then after that, you have the solder mask layer. That's what you'd use to like protect the board from oxidizing or something else. And usually the solder mask is that color you see on the board. It could either be green, blue, black, purple, yellow, matte green, matte black. There's many colors out there. You can even make your own colors if you want to. And next you'd have the silkscreen layer. That would be on top of the solder mask. That would be used to indicate which components are which on the board, and maybe add a graphic or add text or whatever you want it to be. The same principle applies for the double layer circuit board, except you have one on the top and one on the bottom. Now, if you can also connect these two together by having some kind of like through hole, like over here, that would like connect the top and the bottom together. And this is a 4-layer circuit board. This has 4 layers. When you see a layer, that means a layer of copper. And you also have like 8 layers here. And you also have 20 layers. Now, the thing is that if you're a maker or a hobbyist, you don't really need to take a look at 8-layer boards or even 20-layer boards. Reason being that it's really expensive to get 8-layer boards made and 20-layer boards made. 4-layer boards are not exactly expensive. They are pricey, but it's still affordable. But if you're just getting started, then just go with the single-layer circuit board or the double-layer. And for the substrate, as I just showed you, you can get like fiberglass. That's the cheapest and most common. There's also Bakelite, which is much cheaper than fiberglass, but that's not very durable, and when soldering, you can actually peel off the copper tracks, which isn't a good thing at all. You also have aluminum substrate, which is used for, let's say if you have a circuit that's going to be generating a lot of heat, and you need to get rid of that heat. So the aluminum substrate can conduct the heat really well, and you can connect it to a heatsink or something. So yeah, usually you'd find that in an LED bulb or whatever circuit can generate a lot of heat. You'd also have copper base. It kind of does a similar thing to aluminum, but that's a lot more expensive. You also have a flexible substrate. Now, this is used in circuit boards that need to be folded. If, let's say, you have an enclosure where you need to connect 2 circuit boards together, you'd use a flexible substrate circuit board, because you could like bend it in different angles, or you could connect it in really odd places. And it's also used in smartphones to connect the power board to the motherboard, something like that. But yeah, the ceramic substrate is actually used for high frequency circuits and whatever circuit that won't work well with fiberglass. Now, again, if you want to choose which substrates you want, then definitely go with fiberglass if you're getting started with this. If you're doing really advanced circuit boards, then I would suggest you take a look at different substrates based on what your circuit requires. So here's some examples of what you can do with PCBs. And the first one is to make your electronic circuits more compact and professional. So, for example, if you have a circuit, right, and you want to make it into a commercial product. So what you'd first do is prototype the circuit to see if it works, and then after that, you need to make it permanent. So over here, this is a prototype circuit on a breadboard, and this is a circuit onto a perf board. So perf boards are pretty much circuit boards, and only exception being is that they don't have any connections. So what you're going to have to do is just solder up the wires and stuff here and there to make the connections. And the problem with that is that this can take you a lot of time to do, maybe hours. Depends how big your circuit is. So if you want to save yourself the hassle, what you could do is get a circuit board made. Now, it could also even be more cost effective to get a circuit board made because if you just solder up every circuit onto a perf board, it wouldn't be efficient at all. So that's why a circuit board would be a good idea. The other benefit with a circuit board is that you can also put whatever patterns or design you want on it. So it's customizable because essentially the manufacturer, they won't charge you any extra if you want graphics or anything fancy on the board. So they're not going to charge you extra for that. But however, if your tracks or your circuit is really complicated, then what could happen is that during the manufacturing process is that you could have more defects. So okay, moving on. You can also create like cool stuff like badges. So this one here is a tux badge that I designed a while back, and if you want to get one of these made, you can go on Kitspace. I have the design files there, and you can also make rulers and jewelry. So this here is a PCB earring. It's a flexible PCB. And this here is a microcontroller. So what's going to be doing is going to be controlling these RGB LEDs to like flash, blink, and all kinds of stuff. So yeah. So you can also create many more things. You can even create like, if let's say you have a company logo and you want to turn that into a printed circuit board badge. That too you can do. If you want to make a business card with a printed circuit board, you can do that too. So how are they designed? Because if you've ever taken a look at a circuit board and if you wondered like, how did they manage to get like all these tracks onto them? Did they draw them? Well, yeah, you can draw them, but what you use in the industry is an ECAD suite like KiCad, Eagle, Altium, OrCAD, EZDA, pads, and much more. Like the ones I've listed here are really commonly used in the industry. You also have other ones that some PCB manufacturers provide. For example, EZDA, it's with this JLC PCB and LCSE ecosystem where you can have all the parts there, and you can also get the circuit boards made and all that. You also have like other manufacturers that have this kind of ecosystem, but for everything else, they don't exactly have that. So let me just give you a really quick demo on one of these ECAD suites. I'll just open up KiCad. Okay, here you go. Just put this here so that you all can see. Okay, so over here I have a circuit board that I designed in KiCad. Now, pretty much you can just draw tracks and all that. Let me just draw a copper track here. There you go. Okay, track. And that's on the copper layer. then let's go into view. So what this is also going to do is also render your board in 3D so that you can get an idea of how your board may look like. So there you go. You can see my copper track here. It's in gold. The reason why it's rendering it in gold is because like that's the surface finish I set here. And yeah, the gray parts are the solder layer. That's the solder paste layer, yes. And what that is for, if you're getting a stencil made, then that's the layer that will indicate like where the solder paste would be going on to. And in this case, on some surface mount components. Okay. Well, with ECAD suites, you don't. They're not always the same. So some of them, like for example, Altium, PADS, and OrCAD are pretty different. So you might need to figure out which one works well with you, and then you can design your circuit boards. But usually they're with some practice and time, you can get used to them, and you can design circuit boards like drawing a circuit. I mean, like drawing a drawing. If you know what I mean. Like, you know when you like draw something. That's what I mean. Right. And okay. And another thing about ECAD suites is that like some of them here are not always free. Like for example, KiCad is open source and free, but Altium isn't. You can get a 30-day trial on it, but after that you're going to have to pay a monthly or yearly fee of like $10,000, and that's even more for PADS and OrCAD. Eagle, you have the free version, but if you want more features and if you want to design multi-layer boards, then they'll actually start charging you money. For EZDA, it seems like they've started to do that, but it's still free. For KiCad, it's open source, and you can also design multi-layer boards at no extra cost. So the reason why they charge a lot of money for this is that if you're designing a circuit board and if you're using it for a commercial product, then you'd actually get enough money to pay back for the ECAD software. And they also might offer some premium options like a better 3D renderer, like the one I just showed you in KiCad. That's using FreeCAD, but you also have more specialized ones that can render circuit boards really well. And the reason for that would be to like also see if there's any mistakes or if there's anything weird going on in your design. And yeah. So okay, let's move on. Right, now let's talk about making a printed circuit board. So there are like 3 ways you can make a printed circuit board by yourself. The first one being you can like etch one at home. So that method is like really old. That's what people used to do back in the day, because before you did not have PCB manufacturing services like JLC PCB, PCBWay, and all of that. So to get a circuit board made, what you'd have to do is go directly to the manufacturer, negotiate with them, and pay a lot of money. That time, that'd be either hundreds or thousands of dollars just to get a custom circuit board made with your circuit, the solder mask, the silk screen, and the board outline. So they used to like etch the boards, and well, it kind of works, but you are pretty limited on what you can do with it. For example, you can't make multi-layer boards at home. Well, you can, but however, you do need a lot of equipment to do that, and you'll also need to have a very good understanding of chemistry. You'll also need some precise etching machines and all that. Not etching machines, I mean like what do you call them? Yeah, like CNC machines. So the reason why you need CNC machines to cut the board outline and to drill the holes. then you have to through plate it. There's a lot of things that go into making a circuit board. So if you want to etch one, it's totally up to you, but I'd recommend you use something a bit better, which would be the second option, milling one. However, that too, there's a problem with it, because what it does is it essentially just mills away like copper on the board, and that creates like a pattern. In that case, the pattern is a circuit. So the circuits may have mechanical stress during drilling. So what that means is, if let's say you have really thin tracks and you're like drilling around it, so what could happen is that mechanical stress from the drill and drill bits could in fact damage your tracks internally, and you might not even notice that. You might need a microscope to actually see that. But if you're doing really simple prototyping, then yeah, you can mill one away. If you have a CNC machine, you can do that. I've seen people use laser engravers onto a circuit board, but the problem with a laser engraver is that that also takes a lot of power, and you do need a lot of safety equipment, because a laser is actually dangerous if you look at it. So yeah. I also forgot to mention, like, CNC milling PCBs are not efficient and not very cost effective on a mass scale. So if you want to get a proper circuit board made, you'd go with a manufacturing service, because they'll also take care of other things like the solder mask, silk screen, through-hole plating, vias. They'll take care of all of that for you, even castellated holes, panelization. And they can even offer PCB assembly if you want to. And well, you don't just have these three manufacturers. Like, for example, if we go to PCBshopper.com, you can actually find the best manufacturer for your PCB based on your requirements. And in this case, you have like a lot of these companies here. So let's say I want to get a 100 by 100 PCB made. I want 10 of them. I want the least expensive color, and I want the cheapest finish. In this case, there would be lead-free hassle. Hassle stands for hot air solder level. So the finish here, well, if you use leaded hassle, the problem with that is that they use leaded solder, and leaded solder isn't exactly that dangerous, but however, it does not comply with RHS standards. If you don't know what RHS means, it means risk of hazardous substances, and that's something you need to respect in order to have your product CE compliant and FCC compliant. So just go to lead-free board, or you can have it gold-plated. That would be ENIG here, but I'm just going to choose the cheapest option here. Copper weight, you have different copper weights here. So the reason why you'd have different copper weights is, let's say your circuit is really compact, but it's using a lot of current, let's say 2 or 3 amps, and you have a really small track. You could either expose the track, like remove the solder mask and put some solder on it, or you could just have thicker copper. But the problem with having thicker copper is that your board becomes more expensive and it becomes much heavier. The problem with heavy boards is that if you're not a manufacturer in China, because in China, just transportation is like not very expensive if you send it from one part of China to another. If you're in, let's say, Mauritius, then they're going to actually charge you quite a bit for that. And the shipping rates are not exactly that cheap. So, yeah. Alright, certifications. No need. You can also get stencils made. I forgot to mention that with these turnkey services. And yeah, okay. Shipped to Mauritius. They're done in maybe 30 days. So let me just get the prices. So what's going to do, it's going to go on every website, not every website, but the most popular websites which offer PCB manufacturing services. And yeah, you just see the prices. So over here, you can see that Electro has it for like 743 rupees. And yeah, so have other manufacturers. Like, you get the idea. You have a lot of manufacturers here. So yeah, let's go back to the slides. Okay. Now let's say you want to save money on making your circuit boards. Now, what you could do here is parallelize your PCBs. So what that is, it's essentially having multiple PCBs onto one PCB. So let me just, okay, get you, oops, let me just go back, oh no, let me just go back. Okay, so parallelizing your PCBs, well, let me just give you an example. God damn it. Hold on. Right, if you just Google VScore PCB, that's kind of what happens. So you'd essentially be having multiple PCBs onto one PCB here. And the reason for this would be to, let's say, if you're going to get the boards assembled or manufactured, your manufacturer won't assemble one board at a time. They'll need to assemble like 2, 3, it really depends on them at a time. Because if you just make one at a time, it's not cost effective. And they'd also be charging you more money if your board's more complicated and if it's bigger. And also, if they have a size limit, then you might need to also get them panelized so that you can so that it could actually fit in their machine. And if you have an odd-shaped board, then you also need to get that panelized, because most machines that assemble boards, they just take in rectangle or square boards. They don't take in round or oval or weirdly shaped boards. And you don't just get V-grooving, you also get mouse bites. Now, the word mouse bite is kind of like a bite. So essentially, you have like multiple holes here, and you only have these thin pieces of fiberglass holding the tab and the board together. So what you need to do then is just break them off, or if you want to reduce mechanical stress, what you could do is mill it away. Or you could use a specialized tool to remove it. For V-grooving, there is actually like a tool, it's like a cutting wheel that will actually depanelize your boards with less mechanical stress. And yeah, you can also use a combination of both if you want to. So yeah, and another way you can save money on circuit board manufacturing is by switching to a more compact design. What that means is you could use surface mount parts instead of through-hole parts. Another reason why you'd go with surface mount parts is that for the assembly cost, they'd actually charge you a lot less. Because here's one thing you need to consider is that if you're manufacturing a lot of boards that have through-hole components, then they will charge you a bit extra because they're going to need someone to manually place these components on the board, and then it go through like a soldering process to solder them in place. Now, you also have machines that pick and place these through-hole parts, but they might require you to buy a lot of these boards, or order a lot of boards to assemble in order for them to do that. But with surface mount parts, you can still get assembled on a really fancy machine or fancy pick and place machine at a really cheap price. And you can also save a lot less board space, because let's say you have a budget for a printed circuit board or product, and you can only do you only have like a limited board space to make your printed circuit board. because some manufacturers, like the ones, if you go onto like glcpcb.com or all these other PCB manufacturing websites, they'll give you like a board limit of 100 by 100. After that, if it's any bigger, then they'll start to charge you a lot more money. And that's why it'd be a good idea if you can keep your boards under 100 by 100 millimeters. So switching to a surface mount design can also be beneficial in a way that you'd also use less material in a way. That's not exactly true, but yeah. I mean, if you're getting circuit boards made, it doesn't matter whether you have two-hole components or not. They'll make it. It's just the assembly part you have to worry about. Okay, so if you have any questions, just send me an email at nathan@technology.website or nathan@samsung.mu. And if you want to learn more on circuit board manufacturing, then you could just go on the net. You get a lot of tutorials, and you can also take a look at some open hardware products that have PCB designs to just get an idea of how they do it. And if you want to get some really cool circuit boards made, then just go to kitspace.org. And they're not a PCB manufacturer. They're actually like it's actually like a website where you can just have some people's designs, and if you find their design interesting, you can get it made. For example, if I want to get this board made, then yeah, you can go to Kitspace. You'll have like a bill of materials, and you'll have like different manufacturers like Eisler, PCBWay, or Sedge Park that can make your boards. So you just click on it and automatically upload the Gerbers, and you just get the boards made. And what else? And one last thing before we end the session. When you get circuit boards made, you also have to watch out for really simple manufacturing defects, because no matter, even if your circuit fits with their standards, like every PC manufacturer, they give you like a certain like standard you can make your PCBs at, like how thin the track should be, how small the holes should be, and all that. So even if you have gone like close to like their limits, you also have to watch out during the manufacturing process, because if your board's pretty complicated, then what could end up happening is your boards would have, you get more defects. And it doesn't matter whether it was their fault or your fault, they'll still charge you money for the board, even if it's a defective one. And if you're making multi-layer boards, that can be very expensive. So yeah. And I'd also like to mention that Technolog is doing a giveaway on some electronic modules and stuff. So all you have to do is go to this link here and fill out a form, and I'll draw out 10 lucky winners. There'll be about 8 winners, local Mauritian winners that will win electronic modules or some PCBs and Technolog merch. And there'll be 2 international winners that would receive a $1 or Sedge Park gift card, so that you can get like a circuit board made. And well, that's it. Thank you for attending my session. Again, if you have any questions, just send me an email. Okay, peace out.
Hey guys, thank you for watching. Thank you for watching the presentation. That was Nathan Manga doing a presentation on printed circuit boards. Girish, now we can have a short break, and we will be back at 1400 hours Mauritian time for another presentation. Girish, could you give us some information about the next presenter, please?
Yes, our next presenter will be Nisha Apana, who is a product manager at Ring South Africa. It will be on build and program an interactive robot. Maybe it will be a demo. Let's see. For now, let's take a break.
Exactly, that sounds like a very interesting topic, robotics. Guys, we will be back after the short break. See you in approximately 30 minutes. So that will be 1400 hours Mauritian time. Thank you.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
21C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me
take the 21 C skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite. To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail, and healthcare sector. We are proud to stand alongside South African banks as their technology partner. To name a few, ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services. Done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Ticket and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched a data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully, knowing their support is in good hands. We're on track to become an AWS Premier Partner. Fingers crossed. We're proud to give back to South Africa and work with partners, Africa Tickle and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
Hey guys, we are back in the afternoon show of the Virtual Developers Conference. It's 2 minutes to 1400 hours Mauritian time. Girish and myself, Ish, we are back and I will let Girish introduce our next speaker. Girish, it's to you now.
Yeah, so we have with us Nisha Apana, manager at Ringer, South Africa. We have introduced this talk in our last, it was a pre-recorded session. So yeah, we introduced it at the end. It was on build and program an interactive robot. So maybe I will pass into Nisha. She could talk a bit about herself and start the presentation.
Thanks, Girish, for that intro. So as Girish mentioned, I'm Nisha Apana. I've been working for tech companies for over 15 years now. I've worn several hats over the years. And today I'm product manager for Ringer South Africa. I chose the topic build and program a robot because I really believe this is going to be the tech of the future. And the objective is to ensure that all of you feel that you can create a robot at the end of the day. So after the end of my presentation, I hope you will know all the little steps required to do so. So let's dive into the agenda. So first we will cover the 3D printing part. I will show you what are the components that you have to download and print on your 3D printer. Then we will go ahead and assemble all those different electronic components as well as the 3D printed parts. And finally, we will get into the fun coding part where we'll get to make your little robot move, right? So the agenda is simple, just 3 items, and I hope that you'll get all the steps. So let's get into the 3D printing. So you have to go and first download the STL files. You have to give credit where it's deserved. So the person who created those STL files, his name is Camilo Para Palacio. I hope I'm saying his name correctly. He's a product designer and founder of Auto Do It Yourself. And I've put up the link as well at the bottom, which is on Wikifactory. So when you go to that link, you will see that you will have access to 5 STL files. So there will be one for the head, as you can see in the picture, one for the body, one STL file for the legs and the arms. You're going to print it 4 times because you just need one STL file for the 4 items. Then there's one for the grip. You print this twice, and then one for the foot. The next step after you've downloaded all your STL files is to make sure you slice it. What that is that when you buy a 3D printer, you will get access to a slicer. I personally have an Ender 3 Pro, and the slicer that I'm doing is Quality Slicer. So you go and you click on File, load model file, and then you load that STL file in your slicer. It would appear as the image that you see here. So this is the feet of the robot. And so then you go and click on Save G-Code. The next thing that after you save the G-Code, you have to go ahead and prepare your printer. So this is a photo of the printer that I have at home. So you click on the little knob at the bottom, and then you select prepare, and then you preheat PLA. PLA is your filament that you're going to use. Well, I'm using PLA. You can use other type of filaments as well. After you preheat the filament, you have to load it in. So next to the extruder, you press the knob and then you push the filament in, and you push it as far as you can. And at the bottom of the nozzle, as you can see in the screenshot, you will see the filament, the melted filament coming down. That's when you know that you have pushed it far enough. The next step, I'm assuming this is the first time that you're printing, so you haven't leveled the bed yet. Some 3D printers available out there do the auto leveling. Mine do not. So I had to manually go and make sure that the bed was at the right level. So what you do is you have to bring the nozzle at the different spots. So number 1, 2, 3, 4, and 5. There's a G code that I had that would automatically move the nozzle for you, or you can manually do it as well. Then you put a piece of paper just between the nozzle and the bed, just to make sure you leave just like the space of a piece of paper. And this will ensure like your print quality is good, because you shouldn't have too big of a space or too small of a space. So after you do the bed leveling, you move on to the print, right? So you saved your G code already into like a memory card. So you put that memory card into your printer and you click on initf card, and you open your, say I put like autohead.g code, for example, and you load it in. Then hopefully you should get something like this when it's printing. So I'll put a little video of when I actually printed the head of my little robot. So that's how it should be. All right, so at the end of the day, you get that head. Next. Okay, so you do that for all the components that I've showed you, but there could be, like it could be that you want to modify it, which it was in my case. Like, yes, there was free designs available, but then those are still files, so you can go and customize it as you wish. What I did at first was use FreeCAD. It was a Windows application that I downloaded in order to make a hole inside the body. Then I found something that was actually much easier to use. I'm just going to show it to you quickly. So if I just bring this window in and click on create new design. So this is Tinkercad. I recently started using this and I found it quite nice in order to do your designs. Let me just load the body in. This is taking a while. It might be the internet connection. Okay, yeah. All right. So now that you have your body in, you can move it around like this, right? You can play. So you select that you want to join this area. Then you can pull like whatever shapes that you want. So we're going to be selecting like a box here, because we wanted a little hole. This is for the screen that we want to add actually. Then what you can do is you can actually push the shape in like this, and you will see that it goes inside, and we can use this to create the hole, right? So what you do next is select hole here. And then you group it. So once you do this, already it's so fast, like it's so simple that you just like modify your 3D shape that you had, like, you know, that was free, and you can just like, you know, customize it as you want it. So that's pretty cool. And then you can just go and export to like the STL file and go and print it. So that's Tinkercad. And I think that's, for me, this was the easiest 3D software that I've used so far. Feel free to comment on the YouTube channel regarding what you use, and and what you like. I'm happy to know if there are like more options that you fancy. So next is the assembling, right? So now you've printed all your parts, and we have to assemble the little auto, which is on the right of the screen. So when you're gonna assemble auto, you will need some components such as the shield, the Arduino Nano, the OLED display, and 6 servo motors. Then you need the ultrasound sensor, a buzzer for sound, a switch, and 24 female-to-female wires. Now, so the steps into assembling the body is you put the 2 servo motors inside on the left-hand side and the right-hand side of the body. I've put the instructions on the right so that you can see how it goes in. Then the next thing was the legs that you would attach it to the body. Then we move on to the feet. So if I just play a little video, you can see that, you know, the building process. So here we just like testing the servo motors that we assembled for the body, feet and legs. Okay. Next is putting in the hands together, and I'll just show a little video about that as well. So it's nice to do the testing, like, you know, gradually as you're building, just to make sure that everything properly, because at the end of the robot, it's going to be more complicated to do that. So as you're building, test your servo motors and see if like all the movements are correct. Next is actually the brain, right? So we're gonna put, you know, the shield as well as the Arduino Nano inside the head, and then luckily, like, you know, the instructions from Auto Do It Yourself came in quite handy. Like they will actually tell you what pins, you know, you're gonna put the servo motors in on the shield, right? So you can see that the right foot should go at number 5. The left foot should go at number 4. And then you need to just ensure that your ground voltage and signal cable goes into the right place, and all that is indicated on the shield. So, so it's pretty straightforward. Even if you don't have a background in electronics, I think it's just follow the instructions, and then you're good to go. So something that's different from what the instructions came with was we added an OLED display. And for this one, like, you know, you would have to connect the SCR, SDA, and yeah, and the ground cables correctly. But all this is indicated on the board as well. And then you have to put the buzzer and the battery and the switch. And the battery and the switch is used mostly, like you could connect your robot to a USB cable, and then, you know, it will have enough power to do the movement. But in case you don't want it to be connected to by USB and you just want to play it, like, you know, on your table or something, then you can just use the batteries. So let's get into the coding side now. For further coding, you will have to download some libraries. So Utter comes with do-it-yourself libraries that you can get on GitHub. So you download the zip source, and then you go into the IDE and include the zip library as I've shown in the screenshot here. The next library that we will need will be from Adafruit. So especially the Adafruit SSD 1306. This is used for the OLED display and in order to draw on it. So, and that one you usually include it by going to manage libraries and then selecting the library from there. So I like to implement and test straight away instead of waiting to the end. So whenever I add that library, I will run the examples that comes with that library just to make sure that everything is working fine and everything is connected, especially for the OLED display. In case you made a mistake somewhere, then the example is quite handy to make sure that this is running correctly. I do have a video of how the example looks like. I think this was a test for the OLED display that I ran. And then another cool example to run from the Auto library will be the Auto O moves. It's like the different movement that Auto can do. And that would just be like a good test. All right, so now let's draw on the OLED display. So this is the code to do that. I'm actually going to pull the ID. So if I go a new sketch, and so let's just test this out in order to do the initialization. So first you would have to include all your header files and initialize some of the parameters. For example, let me just zoom this in. Yep. So include all the libraries that we've just added, and then initialize your screen, and then run this. This is an interesting line of code. I've hit this a number of times. This is when you start to, it allocates memory. You're quite limited in terms of memory when you're coding on the Arduino Nano, and you need at least 1 KB memory for the OLED display. So whenever you're having multiple things going on, so you will hit this. And in order for you to, let's say we want to make Auto smile, right? So let's create a function that's called Auto smile. And then let's call this. Yeah, I think that should be good. Let me just save. And let's compile it to make sure we haven't made any syntax errors. Okay, there was one. Okay, so we'll just say capital O. All right, I'm now going to be uploading the code. I'll just make sure the port is fine, yeah? So if you can show the screen of the robot. So we're going to try to draw a smile after I upload the code in order to draw a smile here. Hopefully that works well. So it's uploading, as you can see in the share screen. And now we can see that Otto is smiling at us. All right, so I'm going to put it down and go back to the slides. Okay, this is what we did. We did a smiley face. Just for information about what those numbers are, they're basically X and Y coordinates, and then the number of pixels. So the first one, 0, will be the X coordinates, and 10 will be the Y coordinates. So basically, what I did was just draw a line like this, and then a straight line, and then a straight line up. So pretty simple. Now let's make it move, right? So I quite like separating the two, because so we did the screen, and now we'll do the playing with the servo motors. So you would have to again do some of the initialization. So I'll go back to the code that we had. Here. And what we'll initialize now is use a second library. So that was Auto Humanoid library. Then you have to sort of define the pin that you're going to use. Obviously, you could put the number directly in, but just use some variables so that you can remember what it is. Here's where you defined Auto. And next, in the setup, is this initialization. So just passing the variables into your constructor, and what I've written here is some default moves that, so I've just replaced the smile because there's a smile in there already. And so what I have is, let's write some dev context on the screen: walk, jump, bend, and then shake the leg a little. So that will be the little dancing move that Auto can do. There are a lot more options that you can play with. This is just an example. I'll just copy the different functions that I have. Right, so while doing that, so what I'm doing is I'm sort of combining the code for the OLED screen and then with the action that Auto is going to do. So smiling before bending, or laughing before shaking the leg. And that's basically the similar type of code of what we did for the smile, but just a different drawing. And for the white dev context, what I've written is just, DevCon rocks. Just to show that you can also write text on the screen. It doesn't have to be like a drawing. Let me just compile this. All right, so I'll move this here so that you're going to be able to see the movement of the robot. And Ish, if you can change the camera view if you haven't already done so. Then we're gonna upload the new code in. So it's uploading. And now we see some little movements from our little robot. So you should see DEFCON Worx doing some bending. You're gonna see the shaking of legs soon. There you go. And a little laugh. And it's that smiley face before restarting again. So yeah, I hope you.
Can you please bring it closer to the camera? We can see it, but it's too small.
Okay, yeah, I can. Can you?
That's better. That's better.
Okay. Yeah, you probably won't be seeing the screen so much, maybe, but at least you can see the movement from it. Not sure if you're seeing the legs here, though. Cool. I can also unplug because I put battery in, so logically I can unplug it, right? And then let me just put it back into a good position. Then I can make it run on battery as well, right? So yeah, I mean, you just saw it. It's just a few lines of code. It's not really that complicated. And then, I mean, I'm supposed to do like 45 minutes, but in 25 minutes, we've already gone through all the steps that you will need. But I have some additional information, so I'll just turn that off. Let's go back to the slides. Yeah. The additional information is like gotchas, right? So when you're coding, is like, I thought it was going to be pretty much plug and play. But then when you start to do your own thing and you don't just follow the instructions, which was adding the other display, then you start to get into, okay, conflicts. So what I did there is, what I noticed is auto libraries already had some Adafruit code. So, and they were also using doc matrix in the original version, which is not something that we're not using. So I made sure the auto library doesn't include the different files because we're not going to be using them. So you go into users documents and then Arduino libraries and auto do-it-yourself libmaster in order to find all the, because it's open source, right? So you can find everything and in it. And another gotchas was memory. I think this is an interesting one because years ago it's something that we used to care about. Then obviously over the years it's something that we no longer care because we have so much memory. So we never had to optimize our code again for to cater for memory anymore. But when you start to work with microcontrollers and things, then you get back into that initial game. Right, so interestingly, what I found was there were different types of memory. There was flash memory, static RAM, as well as EEPROM. And the one that bugged me a lot was static RAM one because that was only 2 KB of memory, which was not a lot in order to work with the OLED display as well as your arrays and things that you're going to put into memory at one time. So even though at compile time, it says I'm only using 41% of the dynamic memory, but when the program ran, then I ran out of memory. So how I went about handling that initially was okay, look into the auto libraries code, and I found out he was using so every time he needed an array, he was just creating a new one, which would create use more memory. So I modified the original 809 code in order to just like use one array in most of the code. So you will see that there was the old code and the new code is on the right. So I would just have one that has, I noticed it was only using like 6 positions anyway, whether it was moving up or down. So I just modified the one array and then moved the servers. Then I modified the same one and insert the new numbers into it and then move the second servers. So that helped me move a bit. So I managed to do like 2 other lines of code with this, but it was still not enough. After a while, I still ran out of memory again. Then what I found out is that you can actually code some of your like constant static variables into program memory. How you do that is you will see that this is the old code on the left and the new code is on the right. You have to specify prog mem, and when you're defining your variable, and then so especially I want like arrays, that was important. Maybe if you were just like an integer, it would not be so much, but arrays was killing me when I was programming it. So so I use progmem, and then when you're reading from that array, then you have to specify pgm underscore read underscore word, and then you put in the values of your array. So yeah, so that allowed me to like combine the OLED display and do all the different movements that I've just showed you. So moving on with my objective, the objective of the talk to show you how easy it is to program, not only program, but build and then program your own robot. And it has been done in like in 30 minutes. So what I want you to do now is like, go out, look at all the different versions that people are creating, because it's created, they created one version, but it wasn't meant to stay in that state. The idea was to make it open source and then for people to use their imagination and then create their own version of their little robot and just use that knowledge. So there are over 80 remixes out there and over 10 different configurations. So we've done the humanoid one, so the one with the hands as well. But I'm finding like, now that they have the wheel as well, which is going to be pretty cool to code the different movement if you have a wheel. So that's nice. So now you have to make your move, and thank you.
Nisha, thank you very much. That was one of the best presentations since yesterday. Girish, do you agree with me?
That was one of the best presentations.
Like, you respected time, you started on time, you did not go, over. We did not have to show signs telling you that you need to stop. Your flow on the code was right on spot. Your presentation and of course you had a very cute robot with the smile and the DevCon rocks, and especially the little feet, when it was doing like showing how the feet move.
Flipper.
So that was really cool. And I can see there are comments. Vidushi is saying that it is going to be the end of the world. This is how Skynet begins, and he's going to stockpiling toilet paper already. However, we have one serious comment by Adit Santoki, who said it's a nice presentation. And I think he read your profile because he's asking, based on your experience as a product manager, is it challenging to develop a quality product, and how do you ensure that any product meets quality requirements? Well, I believe this question is out of the scope of robotics and anything, but it targets more about, your job profile and the kind of things that would you like to answer something?
Yeah, sure. So the thing is, like, it's all about like having the right processes, right? So I know that when I started, in the tech industry, is that you have like one person that does like everything, right? Nowadays is that we're working with like UX teams. Like, it's not like we have like, for example, in the company I work for, is that I have one person who does the UX, and then we also have like an experience cube team that we call, and it's like our experts in UX, right? That we can sort of like peep into and get like, you know, some expertise, UX expertise, for example. So in order to make sure you have the right quality of the product, like you have to dig into like some of the different experts that you have in your company. And also about making sure you do your planning correctly, like, you know, you follow like Scrum methodologies, you do your sprint planning, and you ensure like, you know, you don't overwhelm all the devs as well. And yeah, so you need to have the right processes and pick into some of the experts that you have in your team in order to ensure that the right product gets rolled out.
All right, cool. And I'm sure, sorry, Nisha, you wanted to add something more?
No, that's it.
Okay, I just heard your voice again. I'm sure that people can reach out to you on social network if they want to ask more about this product quality, ensuring product quality question. We have one more question coming from, well, Adit, thank you for your answer. And we have one more question coming from Eric Durand, you know, from the Mauritius Makers community. And he's... Yeah, in fact, earlier on during your presentation, he was happy about Tinkercad, something that he just found in your presentation, and he's asking the question: with Tinkercad, can you change an existing dimension from an imported STL file?
I've recently just played with Tinkercad. I actually didn't use it for like, you know, creating this. I use FreeCAD, but that was something like I recently found, and I wanted to show it because I saw how easy it was to modify things. I think you should be able to do it, but I haven't done it myself.
Okay, all right. So I think on the comment side, it is we see General Plus also adding on Eric's comment. So again, I must say I'm impressed, Nisha. 35 minutes, you've been able to cover a lot. You've been able to do a demo, and you've been able to interact with our dear viewers. Again, thanks you very much. And it was a pleasure to have you on the virtual platform of the Developers Conference this year. Do you have some final remarks before we end this session? Would you like to say something to I don't know, fellow makers or people who watch this session?
That's a good idea. Actually, we do have like a Mauritius Maker community that, you know, where we get together and we do that kind of like tinkering. As you saw, like, you know, product management is my main job responsibilities, and obviously we don't do that at work, right? So but what happens is that, you know, we're passionate about tech in general. And that's what's nice to have, like, you know, a community like the Mauritius Maker community, where you can discuss like all kind of like, you know, technologies or electronics, 3D printing, and anything that sort of interests you. So feel free to, you know, there's a Facebook group that you can join, and yeah, you can be part of it.
Cool. Thank you very much, Nisha. Girish, your closing remarks, please.
You're
muted.
Yeah, so yeah, for me, it was the most interesting talk of the day. Even the viewers, I think we got the most views in this session. I don't know if you
how many views
saw that.
Well, you peaked almost 30 something.
Well, okay. Maybe it's a colleagues at work actually that joined in the presentation.
But you know, Nisha, you've been in our previous DevCon conferences, and getting 30 people into one room, you know, it's a big thing. So congratulations, you had a very successful presentation. And go on, Girish.
It was a really nice one. I'm someone really interested in robotics, so that was a great talk to me.
All right, feel free to feel free to connect on LinkedIn, and then like if you have any other questions that or yeah, you can just shoot.
Okay.
All
So I
right.
think.
All right.
Okay, bye.
Allez, bye bye. Girish, I'm switching to split two. That's it, Girish. It's you and me now, and we are 14:38 right now. So we do have some time before the next presentation. Would you like to give us some information about the next presenter, please?
Yes. We have actually two speakers next. They are going to talk about mood recognition with machine learning. Our first speaker will be Ramlekhan Akshay, and second one will be Pravish Babaji. Yeah, they both work at SD Worx. Maybe we can introduce them in our next session, Ish. What do you say?
Yeah, sure. Of course, it's just to give our dear friends in the live stream a heads up about what's coming at 1500 hours Mauritian time. Stay tuned, guys. We'll see you in about 20 minutes. Thank you very much.
Allez.
Hello guys and welcome back to the Virtual Developers Conference 2020. We are almost in a few seconds, 1500 hours Mauritian time, and I'm going to hand over to my co-host Girish, who is going to give us some details about the next presentation. Girish, to you now.
Yeah. Okay, so we, as informed earlier, we are now going to have a presentation by two guys, Ramlakan Akshay and Pravish Babaji, who works at the SD Work. Akshay is actually the service delivery manager at SD Work, and Pravish Babaji is a software developer at SD Work. We also use this opportunity to thank SD Work for their sponsorship to our event. Okay, so yeah, Akshay and Pravish will be talking about mood recognition with machine learning. I will hand it to them and let them start.
Thanks, host. Thanks, guys. Good evening. Maybe we can just start. Today, together with Avish, I'll be showing to you the mood recognition with machine learning that we made. Can you just move to the agenda for me, please? Yeah, and for today, we have first the evolution of AI, just to find out what we did with AI since ages now, the concept behind machine learning, and the building blocks behind what's a data model, the coding part that our code monkey will demo to you, and finally the emotion recognition demo itself with the 7 different modes that we have developed. Can you just next for me? First, we'll just start with the evolution of AI. You have two aspects of it. You have the concept of the data accuracy itself, where over time, how it has improved. The first one, the first one is about the reaction upon action. The first concept was developed in 1950, where we first got the first aspect of it, where, for example, every action that you put forward, there was a proper reaction to it. That was the native one. And then earlier, at a later phase, next one, please. At a later phase, what we also saw, about 40% in terms of data accuracy, it was a mixture about with the actual, if I can say, reaction and action and reaction, and also history, bits and pieces of historical data. The first one was about 2000, an AI concept, where it was with the company Sony that they first developed the first humanoid. Next one. Then in 2000, early 2000, there was the introduction of smart application with about 50% of accuracy, where there was a decision based on data trend and also average. And then we later saw that this further developed with 2010 with the concept of Apple, where they first embedded the first type of AI within their iPhone with virtual assistant like Siri, and that was a bit of a change, because there was also another aspect of it, the data scientist. Today, previously it was only based upon historical data and trend, and now something that was interesting, it was also the came up of the model, where the data scientist was like preparing the various data and feed it in the model to just have the AI more accurate. And now it's speaking about 85%. Next, please, for me. On the concept in 2014 was the introduction of AI by Alexa, by Amazon, where they were leveraging about data accuracy, precision, trending, and now the precision was about 85%. That we really saw a big change in the pattern, where AI was really assisting us based on our trend preferences to enable us make shopping. One example was Alexa on Amazon. And the latest one, next please. And for the next one, it's the new one, which actually with 90% of accuracy, where there was the most powerful model that we can see today, where AI is all around us within the small application. You have it within various fields like medical field, aeronautic, just name it, AI is there now. That was for the evolution of AI. Something which is quite interesting here. You see that over the time, the chances for error has diminished, and that's what we are aiming today with the evolution of AI. We'll just change a bit about what's the trend. I already talked about AI, and the introduction was about machine learning. How you put both of them all together, AI and machine learning today. We'll just talk about, first of all, artificial intelligence, the AI itself. The concept of AI is quite simple. It's just mimicking the human brain into machine, so that it can enable the machine at the end of the day to make actions or even take decisions. And under part of it comes the machine learning, which we are going to go into more details today. The concept of machine learning is the ability of, if you want, enable the machine to really learn and improve based on their experience upon the model, the data that we train them. It's just like a baby. The further that you train him or her, he or she is able to just make proper decisions and learn as he develops in a child, it goes on teenager and then adults. It's the same concept. Then the other concept that we also have within the AI family is the deep learning. Next, please. The concept of deep learning is, furthermore, is the ability about mostly towards AI itself, machine learning, but some steps further, it's actually training the model to learn out of it, out of these learning curves, if you want, and make proper decision over stuffs. We'll just stick to machine learning as I told you earlier, and then we'll just shift about how the machine itself can differentiate between various objects. Next, please. Today we'll take just a small example: a pen, and a pencil. How can you differentiate actually between these two? These are called the features, the concept of a feature. And one feature for the pen is that it uses ink, and another feature of the pencil is it uses graphite. And similarly, the data scientist here brings a big change in the modeling, is that they plot these features, they plot that the various differences and enable our model to make proper decisions. You'll see in the graph on the right hand side, you'll see that the red side is the pen and the blue side is the pencil. And even if there's a proper tray, if you want, in between them, there are some pencil that a bit resemble the pen, and vice versa. This is this part. It's the data scientist who will really analyze it and then build the proper model to really train our, if you want, the machine behind to really make proper decision. That's the aspect of the feature. Now I'll just evolve the presentation to talk a bit about the concept. Next, please. Yeah, today there's before talking really into bringing you into more details about the concept itself, let's talk about the approach. There's two types of approach today. There's the traditional approach where today, traditionally, what we were currently doing is that we were, for example, coding, building the rules, and also pushing the data to the system. And at the end, we get the answers, which was pure, if you want, action and reaction. And this model has changed over time to bring the machine learning approach. Within the machine learning approach, you'll see that today the concept has changed. You're pushing the answers to the machine, the concept, the model, and also you have the data that goes with it. Similar like how today a child will be learning. For example, he will each time ask you, why is it like that? Why, and why? And you push it, we push the child with answers. And also when, for example, there's a new data, when he see, for example, a pen or a pencil, he's now able to define what's the set of rules to really differentiate between these two. And that's the new approach. Now we'll see why we have bring the new concept, the new machine learning approach. Next, please. The approach is quite simple, I must say. Why we bring that forward is that one simple thing is that the more rules that you put is more logic, and the more logic brings in more line of code. And that's the simple reason behind why we move from the traditional approach to the new approach towards matching. And let's now get to the concept part. Next, please. And drill down a bit more towards about what we have done within mood recognition itself. Let's take two different aspects, two different moods. On the screen, you can see there's that one happy face and one neutral face. How do I differentiate between the happy face and the neutral face? It's again all the aspect of data. Can you just move for me, please? Sorry. There's the concept of first something which is obvious. When you take, for example, the picture from what I took earlier, the example within the slide, you see that the picture was colored. The first thing that you really need to do for the mood recognition part is to bring down, if you want, all the various distortion. We'll just pass on it like a filter to bring the image in black and white for a faster processing, of course, and also remove like shadow distortion on the image itself. And the other concept behind is converting that particular image to a binary. It's at the end, the way that our model will be trained, the way that you inject data to our model so that it can learn out of it. Once you have the concept of the binary, then you can plug it in the model to at a later phase bring in feed the data, if you want, the model data set. That's what we call the model data set. Actually, it's the training behind the learning out of the binary data that you push to the model, just for example, the machine learning concept that we put forward to make the proper decisions. Now I just pass on to Favish that will be covering the building blocks part and also the demo. Over to you, Favish.
Thank you, Akshay, for this great introduction to what we try to do. So taking in tune with what Akshay just mentioned, the traditional approach versus the new approach with machine learning. So if we had to code the application that we would be able to differentiate between two or more different types of emotions from a picture. So I guess in general, we'd have to just pull in an image from the webcam and looking at the content and try to how would you tell like what emotion is actually being displayed on the photographs. So it would be very, very complicated to firstly code this part and to take into consideration all the different types of skin tone or different types of faces or pertaining to the genders, the age. So it would be a very lengthy piece of code to be able to create such an application using the traditional method. So what we try to do was actually broken down into two different parts. The first being the training part and the using part, which is basically the inference phase. So like I just said, the traditional model, it would be a very long piece of code. We were able to do this with just 50 lines of code in machine learning. So taking in mind all the diverse shapes, skin tones, and sizes of the faces, we created a dataset containing around 33,000 images that were stored in their binary format. So this is the data that the model actually takes in to be able to learn the different types of faces and what emotions that they are displaying. So I'm moving to the next slide. So this is the inference phase, like I just mentioned. The main phase of the application is the training part, but when you actually consume the model, so when you pass in the data that we want through the model will be able to give us a prediction on what it thinks the picture is displaying. So I'll just take a step back and go back to the training phase. So as you can see on the screen on the top left, there is a snapshot of our data set. So here we can see just 12 lines. We have around 33,000 images that are stored in their pixel format. And with the first column displaying the emotions, so we have 0 to 6, with each binary number mapped to one type of emotion, and these emotions are taken from the FACS system developed by Dr. Paul Ekman, who states that there are 7 fundamental human emotions. So this is a bit on our data set, and we used the traditional approach of splitting our data set between 80 to 20% to train the model and the 20% to test the model. The images are, of course, stored in binary. They are preprocessed grayscale images, which is better for the model to actually learn about it. So I'm saying model a lot. So the model is actually the neural net behind the whole system. We used a 3-layered convolutional neural net to go through our training process. So I just skip a bit to our demo and show some code to go through it. So just let me bring in my IDE. Okay, so I'm using the Jupyter Lab. Can you see my screen? The code.
Wait, we can see your desktop with the Skype. I think it's wrong.
Okay.
Now it's better. Now it's good.
Okay, thank you. I'm using multiple displays. It's obvious I'm a coder. Anyway, so we'll take a look at let's take a look at the dataset once again. So this is a CSV file where we stored all 33,000 of our images. So the images, like I mentioned, represent the various emotions that are labeled in the first column. So 0, it's angry, 1, it's happy, 2 is sad, and so on until 6. They are mapped according to the standard set by Dr. Paul Ekman. So each of these emotions, each of these images are map to the emotion accordingly, and this is where we use it in our training part. So I created a 3-layered neural net with each convolution taken in the image layer by layer. So I run the code on 100 epochs. So what 1 epoch means is that each image goes through all the neural links one time. So with 100 epochs, it went back and forth 100 times individually. So when you multiply that to the 33,000 images and the 3-layered neural net, so it's quite a lot. So there's a lot of training that took place, and this is actually what helped us obtain a very good accuracy. So the accuracy we were able to get to was around 79.8%. I have a small snapshot of the accuracy. Okay, so here at around 100 epoch, the accuracy was, the test accuracy was around 79.8%, and the train accuracy was 99.2%. This balance is not actually a big deal. So what it means is the data set that the image was trained on, if we use the same image to test the model, it would return 99.2% accurate all the time. But if you use another image that the dataset actually was not exposed to, the accuracy would be much lower. So it's around 79.8%. For us, this was actually a reasonable accuracy. 8 out of 9, 8 out of 10 times. So we were able to display the application well, the result well. So this is the first part of our application, the training part, where we train the model and we store the information somewhere. But now we have to use the model that we created. So this goes into the testing part, where we feed in an image that was not, that we didn't put in the data set, and we try to see if the model was able to pick up on what emotion is being displayed. So I'm not sure if you guys can see the code actually.
Wait, Bhavish, we can see the code, but I will let me better improve the resolution on the live stream to give you a better confirmation. Could you increase the font size a bit?
Yeah, I can improve.
We can see the code, but it's small. A bit more, please. Now it's way better. Go on.
Okay. So as I said earlier, the data set was stored into 0 to 6 for each emotion. So the model has no way of knowing which emotion it is. So here we class the different emotions into separate classes. So as you can see, we have 7 different objects. So pertaining to each matching number, it will be able to map the difference, the similarity to the emotions that we create. So this has to be exactly the same as we created in our dataset to be able to get an accurate enough result. So here we are loading the model. The model is stored in an H5DF file because we can't actually see it. So we have to load it through with Keras processing to be able to use it. So I'll just run it real quick. Okay, so as soon as I run it, there's a small tick into GUI that I created quickly to be able to browse through a file. So I'll just browse the file, and this is something, this is my face, so I'll just use that to try and see if there's an accuracy. Okay, so it's almost instantly I'm able to get, well, if we all agree that I did happen in the picture, so I'm able to get a very good accuracy for the emotion that is being displayed in the picture. But we can also see there is a small similarity, there is a small index for each of the other emotions, but because we do not actually have a 100% accuracy, and the application is actually not telling us, okay, this is a happy picture. It's merely making a prediction on what we actually taught him or taught the model during the training process. So this is what's actually going on. So I just do it for another picture, and again choose another one. So yeah, so again it's the same result. So the person is visibly angry. So the emotion is significantly higher in the anger column, and there's a small percentage for all of the other emotions, but we do have a very good accuracy for the model. And if you guys can see how fast the processing actually is, it's almost instantaneous and simultaneous. We'll get to the simultaneous in pause. I'll just do another demo real quick with another image. Image. Yes, so again, this is the person is happy and the emotion is accurately displayed. I have to be honest, but there are some images that it won't work on, so because the 80% accuracy, to be able to get, I guess, a better accuracy, we did some tests in this context, and we found that the key to getting a better accuracy is actually to just reduce the number of clashes that we have, because the model is trying to learn several different emotions, and with such a large chunk of data, the data is getting overfitted. So that's why with this kind of processing, and all of this is done on a laptop, it's actually the best we could have achieved, unless we reduce the emotions or use a better data set. So remember I said simultaneous. We also applied the same model that we created on a live video processing feed. So I just try to switch on to the other code and turn on my use my webcam to actually try and display this model live. So again, it's the same concept. It's the same model, same training set, everything. It's just that we created a layer of video processing on top of the model to be able to see the emotions in accuracy. Okay, so I think I have to turn off my camera, my webcam camera, and use allow the application to use the webcam over there. Just turn off my camera real quick. Yeah, can you just, yeah. Yes.
It is still showing your Skype window.
Well, actually,
Part of the window you want to.
no, actually, I want to turn off my camera for Skype so I can use my camera on the application.
Yeah, then try to turn it off on your side and we see.
Yeah. Okay.
That should be fine.
Okay, so it's good now. Sorry about that.
Misunderstood. I thought you wanted
yeah.
to,
No. Okay, so it's better now, I guess. Okay, so I think you guys can see the camera.
Yes, we've put you on full screen. Your desktop is on full screen in the live stream now. We
Okay.
can see you. We can see.
You can switch to the GUI if you want. Okay, so I'll explain real quick what we try to do here. Because we wanted to keep the accuracy good and have a seamless processing in simultaneous with input video, we had to reduce the number of classes in our data set. So we took it down to just happy and angry, and we created another model to train the data set and to use the output on this type of application, because to process the video and show the result almost immediately, that took a lot of firepower, and all of this is being done on a laptop. So as you can see, I'll just come closer to the camera and smile maybe, and it will show that I am happy. I'm not sure if it is doing that. Okay, so it's happy.
Just out of curiosity, can you make
Yes.
an angry face and we see?
Yes. I'm sure it's angry. It's angry. Okay, can you
make your normal face?
Well, my normal face is happy, but
It's kind of funny. Would you agree with me, Akshay? His angry face is kind of funny.
but that's because I'm not usually angry. But well, I think it's working. Do you agree with me, Akshay? With my angry face? So this is actually what we try to do.
Okay, nice.
I can't hear you.
Go on, guys. Yep.
Yes. So if you wanted to extend this to all of the 7 different clusters, it could have been done, but we would have needed a better or more firepower to process this simultaneously. There was another option to just process a video feed afterwards. That would have been the same as the image processing, but we wanted to do it live, which is, I think you'd agree, better. A better application of this model that we created, and I guess it's something that we are very proud of. And I'll switch back to the slides because I guess I'm done with the demo here. Okay, so my slide I just quit. So that was, I guess, the demo. It was a very short demo. We tried to keep it very light, to be able to explain what we did. And this is something that we have been working on for quite some time. I guess since last year, okay? If you agree, yes, it's something that we worked for nearly a year. And we obviously used the application to build other more interesting layer on top of it. Like we explored the idea of doing a IoT layer to display let's say different types of lights depending on your mood simultaneous, or even a created music playlist that depends on what you're feeling So this is there are different types of application what we looked into, and for us the core of the application was the training part, which was done it was done good in my opinion, and I guess actually agrees too. And this is something that we took it further. We published research papers on this research that we created, and it's basically very easy. Like I mentioned earlier, it's just 15 lines of code for the usage of a pod. The training part is actually the hardest part, where you have to create the data set. You have to meticulously write each line of code for your layer. That was the hard part, but once that was done, we had a lot of fun ideas to use the model. We should be the live simultaneous processing. So I think that's all from my side. Maybe Akshay would like to
take the questions now. Maybe we can take the questions.
Okay.
Yes. Okay. Pavish, could you you can enable your camera now. I'm gonna switch you on a different mode, and then yes, we do have a question. We have one question from Christopher, and wait, I'm gonna just switch the scene here so that we have everybody on screen. All right. Yes. The question from Christopher. Girish, can you ask the question from the live stream?
Yeah. His question is, what is the algorithm being used for the artificial intelligence?
It's a convolutional neural net.
Okay. He has another question. According to you, what is the future of AI?
This is interesting. Go on, guys.
Well, I'd like to let Akshay answer first, and then I'll get into it.
Yeah, probably Akshay, here. Because sorry, Akshay. I was going to say probably the question is more suited to you, Akshay, since you spoke about the evolution at the beginning.
Yeah, as well.
I think it's already here, because we already see that, for example, today the AI is like enabling us, aiding us towards decision. And for the future, I see it like even in the medical, because I'm more like doing quite some research in the medical fields also. With the medical within the medical fields, if I can take a simple example, is, for example, today we have the deep lens that is currently while doing a surgery, there's like a camera plug on top of the surgery, where, for example, if, for example, someone is like having like various tumors, and live you can, for example, the AI will interpret, if you want, the various cell, and then deep dive, give you more in terms of details. Like it's similar like that application. I see the future of AI is like really enabling us to make proper decision faster for the humankind. Of course, it's a matter of having a knife. Either you use it to kill someone, or you use it to make food for the population. And it's the same approach here. And if you see the good use of AI, for sure you can foresee situation, and even in automatic car, you can see, for example, for sure we are still not there. We still have like rooms for improvement, but we are reaching at some point of time where we have less errors, and they are able to predict better the results, and also enable us to make better decisions at the end.
Okay.
I don't know if you agree with me.
Well, Christopher has to agree with us. He asked the question. So I think, guys, I must congratulate you both that you respected the time, and within, let's say, 30 minutes, you were able to cover quite a lot of information, including a very nice demo. That was a very nice touch about with the angry face and the happy face. So, Girish, any comments from your side?
Yes, I would like if the other speaker, sorry, I forgot your name. What are your thoughts on the future of AI?
Actually, he's my manager. I cannot actually disagree with him, so I just say
Hey, come
whatever he
on.
said.
You're free to talk.
It's okay for me. Well, I mean, if you look at the IT industry, maybe 5 years ago, I was still in college, so I can't say much, but we can see the evolution of how we are going forward. Like, I worked on this last year, and the year before that, if you ask me to maybe explain one tiny part of what I did, it won't be possible to do that. The interesting thing about AI is constantly evolving, it's constantly changing. So today I was able to create an application that can detect emotions from a live photograph or video, whatever it may. So tomorrow we can't actually know what's going to be happening because of the vast majority of what AI can do. Like Akshay mentioned, with the medical applications, it doesn't have to be limited to that. We can look at how any business is functioning today and see how many things we can actually replace with AI. Even here at SWorx, we have.
I think it's not about replacing, if I can say. It's
Yeah.
about like enabling us, like doing, if you want, more stuff that will add value to the business, and to complement human. Because AI, I don't think will actually replace people, but it will.
That's why I said I can't disagree with him today. So.
Yeah, but the concept is mostly about for the AI, how I see it, it's enabling people, aiding people to make proper decision, and also concentrate about doing like the right stuff.
Well, I just hope that in 50 years, my manager is not a human, so maybe we'll see. If you're still here, we'll see.
I would agree. I would agree with what Akshay said, that even when we look at let's say 3, 4, or even 5 decades before, with the advent of computers and more powerful computers, there was this constant fear that computers would replace humans one day. There won't be jobs. But today, all of you guys are in the urban cyber city thanks to computers. So if we go back to our parents and maybe grandparents, a lot of them thought that computers would replace a lot of jobs. But in fact, what it did, it enhanced the jobs, and there were new kind of jobs on the market. So based on that, I agree with the explanation that Akshay just gave. And Girish, I see that we have another question. Would you like to pick it up?
Yeah, so it's from Adit. How much data was used for training? I think it was for your simulation. How much data was actually used?
Yes, so our dataset was composed of 33,863,000 images, I think. The split was done 80 to 20, so I have to look at that calculator and calculate the 80% of 33,000 images. So it was roughly around 28,000 images. So these are images that are not stored in JPEG format or PNG. They are stored in their raw binary format. So it was easier, I guess, to create. Not easier for me because I had to individually store each of the images in the dataset in the binary and make sure that they are actually matching to the emotions that I created, that I wrote in the first column where the emotions are being displayed 0 to 6. So there's 33,000. So you can imagine how much time it took, but I'd say it was very much worth it because once I got a very good accuracy, 80%. So there the possibilities open up where we could have where we can still use it to create many more things with this as a foundation.
Yeah, that does sound like a very meticulous work.
Yeah, it was.
Girish, any more thing to add?
Yeah, it was mostly. Yeah, I'm sorry. It was mostly. Yeah, it was mostly trial and error to be frank with you. Like the first time after training for maybe on my laptop it took 2 days full, 48 hours. Like the laptop was running on itself, and the first time it returned maybe like 20% accuracy. So I had to just fine tune the parameters and try again and again and again until it actually got to 80%. So that was a year in the making. So it was actually part of my dissertation at the University of Technology, and we took it further and brought it here today. And we plan to take it further than this to be able to use it in a way that we can actually, I guess, present it as a product maybe someday. Why not?
Yeah. And the question from the.
Yeah. Okay, so you already read it. Yeah, let me also question for the live session that you did. Will the camera be able to read 2% face? Maybe that would need more power, right?
Yes, it would need mobile. We can actually use 2 faces, but then I had to distort the quality of the video to be able to fit in both faces to be processed at the same time. But it's definitely doable with a better laptop or better GPU or whatever processing power I need.
We have another question. I think it's okay. Maybe our last question by Deep Sheeter. How much is AI trustworthy to do surgeries compared to doctors in the medical field?
I think Akshay would like to take this one.
Yeah. I think that's why I also mentioned about aiding the doctors towards decision. It's not actually doing the surgery. The AI, the robot won't be doing the surgery itself. It's rather, for example, if there's a decision, for example, something quite simple. Let's say you have virus scanning, and they have learned out of like maybe about 1 million scan and then taking the proper decision. And when, for example, for a patient A, you want to have like the AI respond from the medical, if you want document, you just inject it and then you have the proper outcome. And based also on the medical person's experience and also the AI, and then compare and mismatch result. If there's a mismatch in the result, then go deeper if you want. It's not really about replacing the surgery or replacing the doctor. It's about aiding them. It's actually how I see it.
Okay. So yeah, I think this session was a great success. We also see how much work these guys put in to bring us such a great session. So I guess it was a really nice one. We got interaction from our chat, from our YouTube viewers. Yeah. So what are your thoughts?
My thoughts, I concur with what you just said. A very nice presentation, very nice demo, and very good interaction with our viewers. Thank you, guys. Thank you, Pavish. Thank you, Akshay.
Thank you.
And we just hope that for in the next time we get to do, you guys get to do a presentation in much better circumstances, not during a pandemic and in a physical place where we can interact in a better way. Thank you very much once again. And I will stay with Girish for our next session. So Girish, could you Yes, Girish. Could you give us some details about the next presentation?
Yeah, our next
Thank you. We're just
presentation.
moving out.
Yeah, our speakers are still here. Yeah, good. Yeah, our next presentation will be live from Nathan Margot, who couldn't be live before. He actually did one session during the day, which was pre-recorded, but we will maybe have him on board today. After, I mean, like I think it starts at 16h. Oui. It will be on create your first printed circuit board using KiCad. So let's see what he brings us.
All right, Girish. So, yes, so it's here, and we are supposed to have the next presentation at 1600 hours. That leaves it like 15 minutes. So we're gonna take a short break here, and perhaps Girish is going to get in touch with our next speaker. Meanwhile,
see you guys.
See you guys.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in.
Hey guys, good afternoon. We are back. I'm Ish and my co-host Girish is here. We have our next presenter with us. I'm not gonna spoil the fun and I will let Girish do the introduction. Girish, go on.
Yeah. So our next speaker is Nettobe. He's still a high school student, but he's really good into IT. He's member of a cyberstorm.mu, and he's a maker. I would love if maybe Nathan, can you tell us a bit about yourself and how did you get into IT? What made you interested?
Well, first of all, I actually planned on doing electronic engineering, but then what happened was I actually decided to do IT because it'd actually be much more simpler. But as a hobby, I do electronics and I make stuff. And one of them is like making circuit boards and building circuits.
Okay. So yeah, I think you're a regular speaker at DEF CON. So can you tell us a bit about what is your talk going to be about today? Create your first printed circuit board using KiCad. A little brief maybe, and then we can start.
Okay, so KiCad is like an open source EDA tool, and pretty much anyone can use it, and I'll actually show you how to make your first circuit board using KiCad.
Okay, so I guess it's all yours, Nathan. Come on, go on.
Okay, so I'm going to be showing you guys how to create your first printed circuit board in KiCad. So in this session, we'll be covering what KiCad is, what it can do, and we'll create our first circuit board. So like, what is KiCad? So KiCad is a free and open source electronic design automation suite. And what it can do is you can create schematics, printed circuit boards. You can view your printed circuit board designs in 3D. You can generate Gerber files, the files you need to actually give your printed circuit board manufacturer in order to make your PCB. So if you're not an engineer or a technical person, no worries. Anybody can use KiCad. Now let's create our first circuit board. So let me just exit the slides. Okay. So first of all, you're going to have to download KiCad. Now just go to kicad-pcb.org. KiCad is available for Windows, Linux, Mac OS, and I think FreeBSD too. Yeah. So I'll be doing this on Windows. So I've already installed KiCad. So let me just open up KiCad here. Okay. So when you download KiCad, the first thing you'll see is this screen here. Oh, hold on. I think I accidentally closed this. Okay. So the first thing you'll see is this. So what you're gonna have to do first is actually create your project. So there's this icon here. You just have to click on it. And hold on. Okay. So right, you can save it anywhere you want. For this one, we're going to be calling it DevCon demo. Okay. Right. So once you create your project, you're going to be presented with the PCB and schematic file. So what you have to do first is create the schematic. Okay. So here. Okay, so the circuit we'll be making today is not a very complicated one. It's just going to be an LED and a resistor. You can create more complicated schematics, but if you've never done this before, then an LED and a resistor should do the trick. Okay, so here's some libraries. So KiCad is not going to give you this because that's because I kind of messed up some libraries here and there. But if you just install KiCad, that's not going to happen. So yeah. So let's just put LED. So another good thing about KiCad is that you have all these libraries here. If you ever use in EDA suites, you're going to have to need libraries, and these libraries allow you to like add components to your schematic and printed circuit board. And because KiCad's open source, you get all kinds of libraries out there. And KiCad does have quite a lot of libraries built into it. Okay, so let's just place our LED here. And we'll need a resistor. So in KiCad, if you just type in resistor, you won't exactly get resistor exactly. So if you just want a simple resistor, you'll get R. You just type in R, and okay. Right. So we have our components here, and if you want to connect them, there's this tool here called Place Wire. You get different kinds, but we're just going to be using the simple Place Wire. And just click here, there you go. Right, so we need to like connect these to power. So in your schematic, just go over here, the power port symbol, and let's say we're going to be running this off 5 volts. So let's just type in 5 volts, plus 5 volts, and here you go. So in order to rotate your components, just press the R key, and you'll be able to rotate your components. So I'm just going to rotate it here, connect it directly. So we've already connected the anode part to 5 volts. Now the cathode part needs to go to ground. So let's just get ground. That will be GND over here. Okay. It's connected here and done. So another thing you're going to have to do with your schematic is also like indicate which components are which. So you can easily do that by just double clicking on it. So if you want to do more things with it, you just have to right click and you can do all kinds of stuff with it. So yeah. Okay, so now we've created our schematic here. If you want to add things like the revision number and all that stuff, at the bottom of the page, at the bottom right, you have this this table here. So for title, in order to create text in the schematic, you're just going to have to click this thing here, place text. So let's call it DevCon demo. Now, for the text, you can, you can like customize the size, and you can either have it in normal, italic, bold, or bold and italic. So I'm just gonna go with normal here. So I'm just gonna place DevCon demo here. Now we have revision here. Now what revision is that let's say you create your first circuit, it'll be revision 1. If you create your second circuit, that'll be either revision 1.1 or 1.2 or revision 2. It's totally up to you. If you don't use numbers, you can use alphabets like revision A, revision B, revision C. It's totally up to you what you want to use for the revision. But I'm just going to use revision 1. Just use a number instead. Okay. So over here, you can add graphics and stuff, but we're not going to do that. So yeah. So after you've done this, what you're going to have to do is create a net. So just generate a net list. And what it's going to do is it's going to generate a net list in your KiCad folder, on demo, and just click save. And yeah. Now let's actually move on to creating your circuit board. So, right, just wait for this to open. Okay, it's gonna go a while. Okay, so when you create your first circuit board, it's just gonna be blank here. And what you're gonna have to do first is create the board outline. That can depend. If you already have a size in mind, let's say maybe 10 by 10 millimeters, we can create our PCB to be 10 by 10 millimeters. So if you want to like create the board outline, it'd be a good idea if you can like change the grid size. Because over here you have grid 0.2, 0.1, and all that. So what that is, that kind of like makes, kind of like adjust the precision of the pointer here. And as you can see, if I make it smaller, maybe 0.01, it's more fluent. So yeah, we're just going to make it 5 mil for the grid. And in KiCad, the layers are slightly different if you use Eagle or Altium. But you're just going to have to go into Edge Cuts over here. That's going to be your board outline. Then just click on Add Graphic Lines. Then all you do is create your board outline. So over here we created a 10 millimeter board. It's going to be a 10 by 10 board. All right. Okay, so we created the board outline here, and now we're going to have to like place our components. So you can either do that manually, or what you could do is just load the net list. And let's get a net file over here. Okay, so if you get errors like this, just don't worry about it. Just put update PCB. Okay, so for some reason that didn't add my components, but if that happens to you, then what you're gonna have to do is manually add the components. It's taking a while. Okay, just remove this. Right. Okay, so now we're just gonna have to look for a resistor that would still be there. Okay, so you get different kinds of footprints here. So if you just type in, okay, so you can have surface mount components or through-hole components. So surface mount components, the thing with surface mount components is that it goes on the surface of the board. So let me just put that in the 3D viewer to, let me just adjust the grid to, let's put about, okay, 1 millimeter, right. So let me just put a through-hole component to, down. So you're gonna have all these libraries here, but you're just gonna have to like find the right one for your design. Let's get some here. Okay. Okay, so this is going to be a bit too big, the components. So I'm just going to have to make my board outline a lot bigger. So I'm just going to have to remove this. Outline. This time we'll make it 20 by 20. Okay, right. So at the bottom here, you can actually see that's like showing the length of the line you're drawing. So yeah. Okay, so now let's go into 3D viewer. Let me show you difference between a through-hole component and surface mount component. Okay, let's make this here. Okay, so as you can see here, the surface mount component is going to stay at the top of the board, and the through-hole components will actually go through the board. So the advantage of having a surface mount component is that it actually be a lot easier for you to place. So if, let's say, you were going to make hundreds or even thousands of these boards, it'd actually be more efficient if you use surface mount components. But if you're just a hobbyist, then through-hole components would just work fine, unless you want to practice some surface mount soldering, if you want to get into that. So yeah. Okay. All right, that's much better. Right, so in the 3D viewer, you can actually adjust the board color too. Let me just show you that. So you can adjust the solder mask color. The solder mask, that's the layer where you get the color and stuff. So KiCad does have some predefined colors. Let's say I want to make this board red. Yeah, let's make this red. Okay. So yeah, you can also modify the surface finish. Hold on. Okay, you can change the surface finish to tin or copper, or you can have your own color too if you want to. So yeah, let's change it to tin. Okay, as you can see. Right, so let's get back to the PCB design. And let's minimize this. Okay, so now because our circuit also requires an LED, we'll also place the LED here. Right. So we're going to be using a 3mm LED here. Right. So if you actually made a mistake like I did here, so you can there's this undo button here, and just click that, and that'll undo whatever mistake you did or whatever change you did. So yeah. So if you right click, you can modify the component. But if you just want to edit the component, you can just click. You can just press E, and you can either have it on the front or back of your board, and you can either display the reference number or not. So yeah. So let's just change this to D1. Okay, right. So now let's just redo this netlist step. It should work, but this time just tick this thing here, reassociate footprints by reference. So just do that. So now, as you can see, you have this thing here that's called a net. So what nets do, they show you where the component is supposed to connect. And in this case, this LED here is supposed to connect to this part of the resistor. So for your board layout, you can also modify the where you want to put the components. Okay, let's place it here. Again, just press R to rotate, and yeah. Okay. All right, let's just place it here. Okay, so now once you've put your components and defined the board outline and import your netlist, you're gonna have to put the copper tracks. Now for this, you're gonna have to go into FCU. That's gonna be your front copper layer. Then if you want to modify the track sizes, you can do that. So by default, you'll have 0.25. Yeah, that's going to be here. Right. So I have 0.25. But if you want thicker tracks, that's easy. All you have to do is go into edit predefined sizes. Click this here, and let's say we want our track to be 1 millimeter, or let's put it 0.7. Right. Press OK. Now in the track, you'll get the option for 0.7. Right. So now let's connect this here. And let's say we want to add like a connector or something. Let's just like a pad or something. Okay, so instead of a connector, let's just add a simple pad here. Okay, that's way too big. So again, you have to find the right footprint sizes, because some of them might be too big, some of them might not be exact. If they look the same, that doesn't mean they are the same. So yeah. Right. Okay, let's take this one. Okay, this one's okay. So instead of just doing the same process over and over again, you can just copy and paste the component here. Okay. Now, we're not going to be putting any reference, but I think you can actually modify that. So if you just double click on the pad here, you can change the netlist to, okay, let's say ground. All right. Okay, let's make this 5 volts instead. Okay. So now what you could do is you could directly connect it here. All right. All right, so now you could just do that, or what you could do, you could have a ground plane. So what a ground plane is that instead of directly connecting the board to ground, I mean connection to ground through a copper track, you could have the entire board like with a copper fill that connects to the ground. So let me just show you what that is. So in order to do that, just go into add fill zones. Let's create the, okay, so it's going to ask you what net you want to connect this to. Let's just go with grounds. Okay. Okay, so as you can see here, you'll have like some kind of ground. Now all this copper bit here is actually connected to the ground. So the reason why you do this is if you want to like reduce interference in your circuits, or maybe, I don't know, you just want to. So yeah. So if you already put the ground fill here, but you want to see the copper tracks, you can actually just take this, just take here, you'll only see the tracks, or you can have this here. So, okay, let me just make the screen bigger. Right. Okay, so on your left, you'll have all these options here. You'll even have the layer stack up. And you even have this here, which if this wasn't turned on, you just see the cursor here, like this. So you just have to turn it on in order to see this like line thing. So, yeah. Right, so now let's just view a board in 3D. Okay, so as you can see, it's just a regular board. Okay, that's good. Right, so if you don't want to have a square board, you want to make different shape size boards, you can also do that. So let me just go ahead and generate different kind of board. So Yeah, let's just this. So if you want to not see a certain layer, you can just untick some of these boxes. So let's say if you don't want to see the front copper layer, you just untick this here, and you can like edit the other components. So now let's make our board round. So just going to add a graphic circle. So don't remember to set this to edge cuts. Okay, and let's create a graphic circle. Maybe this big. That should work. Should be front copper. And that should work. So for the copper fill, we're gonna have to redo that because this just looks weird. So let's do it again. To ground. So with the copper fill, you can actually put it outside of the board because it will automatically detect if it's outside of the board or not. So yeah. Okay, here we go. So let's just view board in 3D. Let's drag this here. Okay, so as you can see, our board is now in 3D. So, and also it's round. I mean, you can make other kinds of shapes, but yeah. Okay, now if you want to improve your schematic and all that, you can also do that. So yeah, and also if you want to generate a bill of materials, you can also do that. So yeah. Okay, now let's say you want to get this circuit board made. So what you do is you need to export to Gerber files. So let's just create our own Gerber files here. So in order to do that, you just have to go into plot and okay, so you'll get the layers you need to choose. Just go with these layers, right? And just untick this because most manufacturers, they don't support Gerber X2 because usually if you generate a Gerber file, that'd be Gerber X1. The only difference being Gerber X2 has more details in the file, but some manufacturers, if they use something like CAN 350 to view your circuit board design files, then they may not be able to open it. And you also get the Protel file name extension. That's optional. Doesn't matter whether you take it or not, but according to KiCad, it's not exactly recommended. But even if you send like Gerber files with Protel file name extensions, then you should be good. But we're not going to take that. So now we're going to create a folder, new folder. We're going to be calling that Gerbers. Okay. Just click yes, and yeah. So first, what you do is you just click on plot. So it's created right now. It's created the Gerber files. And we're not done yet because what it's done is it's only created this outline and the copper bits, but for the whole, that's not created yet. So let's create the drill files. Now you get all this stuff here, but just leave it by default. Just use the defaults and just click on generate drill file. So yeah. Okay, now let's take a look at our Gerber files. Right. Just drag the screen here, just give it a minute. Okay, so we're in our DevCon demo directory. That's where we have all the files and stuff. So now what you're gonna have to do is create a zip file. We call that DevCon demo 2. and all you're gonna have to do is just drag this into it, and yeah. Okay. And another thing about KiCad is that you don't just get the PCB and schematic designer, you also get a Gerber viewer, a bitmap to component converter, a PCB calculator. So the PCB calculator pretty much what it does is you can calculate what track width you need, all that stuff. Like, it's really interesting. I definitely recommend you take a look at this. Yeah. So we're going to be using the Gerber viewer here. Okay, let me just drag it over here. Okay. So just click on Open Gerber Files and just go into Gerbers. So just select all of these here. Click on Open. Just ignore this thing here. Okay, now you should be able to see your circuit board in Gerber, in the Gerber format. Now, the Gerber viewer isn't that great, but if you want a better Gerber viewer, then you could check out an online Gerber viewer called tracebase.io. So, let's look at Gerbers here. Okay. Right, DevCon demo. Gerbers DevCon demo.zip. It's taking a while. Okay, let's drag this over here. Okay, for some reason that's not loading. Just reload this. Just manually drag it in. See if that does anything. For some reason it's not opening it. Okay, just ignore that. All right, let's try. Okay, so if you want to get the circuit boards made, all you can do is just like upload these zip files to like a PCB manufacturer, and what they'll do is they'll like take a look at your Gerber files, and what they usually do, they like place out on a panel. So because before, when they used to make circuit boards, you couldn't just get it made like that. You need to buy an entire panel. So what they do now, they just place it onto a panel and they share the manufacturing cost. So if I need like, let's say 3 of these boards, that'll just cost me like $6 at Osage Park. So yeah, got a error here. Doesn't contain a bottom soak screen. That doesn't matter. So yeah. So you also get different PCB manufacturers. You can get JLC PCB here, but essentially they just take your Gerber files and make your circuit board. So in total, that could come to about $6 or even $30. It's not that expensive, and you can also like get stencils made with it too. So yeah. Okay. We just talked about a few tips when using the schematic tool. Like when using the schematic tool, don't make any, like if you want to make a huge schematic, then that's pretty easy. You're just going to have to edit the page size. It's over here. Okay, page settings. So by default, it will be like A4, and you can make it bigger. You can make it A3. Just do that here. Okay, so as you can see, it's A3 now, but we'll just set it back to A4. Okay, great. So if you made any changes, just always save it, just in case, let's say your PC crashes or something. It actually ruined your day if, let's say, you had like a really complicated board design and your PC just crashed all of a sudden. That wouldn't be really great. So, yeah. Right. And another thing is always double check your designs for mistakes and stuff. And always take a look at the footprints, because I've had this before. What would happen is some of the footprints, like in schematic, did look okay, but then in the actual PCB footprint, it actually be something slightly different. That might have been in the older versions of KiCad. I think they might have fixed this on the newer versions, but just be aware of that. So yeah. And because KiCad does use quite a bit of Python, you can also do some like Python scripting and all that stuff. So yeah. I mean, if you're really into Python, then you'll actually like KiCad quite a lot. So yeah. All right. I think I've covered the basics. All right. Okay, if you guys have any questions, just send me an email at nathan@technol.website or nathan@cybersyn.mu, and I'll get back to you in like 1 or 2 days. Okay, giveaway time. So I'm doing a giveaway. So there'll be 8 local giveaways for Mauritius, and there'll be 2 international ones. The 2 international ones would be OSH Park gift cards, so that you can like make your own PCBs, and the local ones will be just electronic modules, stickers, and stuff. So yeah, you can just go on this link, or you can scan this QR code. Okay, thank you for listening, and also feel free to check out my blog, technol.website.
Right, Nathan, thank you very much. That was a nice presentation, greatly done. You respected the time. It was you covered a lot in such a short amount of time. And Girish, okay, Girish also joined us. So Girish, what was happening on the live stream? Was it all good?
It was really nice, but unfortunately, I don't know why we didn't get any audience interaction. That was the only sign. Yeah,
never mind. That's not a problem. Nathan, tell me, would you like to reach out to our viewers so that they can get in touch with you on social networks, Facebook, Twitter, maybe?
Yeah, and I also, in my previous slide, I actually had my this is also my email. So if you have any questions, or if you want to like ask questions about the session, you can like just send me an email. So.
All right, that's great. Once again, Nathan, I would like to thank you for your time and for your presentation. Nicely done. So, okay, Girish, I'm switching to the split 2, and maybe you can give us some information about the next presentation that is going to happen at 1700 hours. And if I'm not wrong, it's not a presentation. Go on, Girish.
Yes. You really want us to spoil the fun? Okay. I just briefly tell you guys, it will be a podcast, a battle between Dogger and Podman. All the audience is invited. You're here. We need to have a nice conversation. We will have a guest with us ish. I think we will have a guest with us.
Yes. In fact, that's interesting, because initially we wanted to do a podcast. Girish and myself, we would talk about the topic Docker versus Podman. But then finally we got a guest. We're going to reveal the name later when the podcast is going to start. So stay tuned. We are about let's say 20 minutes to 1700 hours Mauritian time, and Girish, we should remind our viewers that they are allowed to comment, to send questions, and anything that they would like to contribute in this podcast.
Yes, they need our next podcast is going to be real fun. So stay tuned in.
Yes, we aim to make it fun. So guys, we're going to have a short break here. Maybe those who want to grab a coffee, grab I don't know, some biscuits, and be ready at 1700 hours. Okay?
Allez, ciao. So hello guys, we are back, Ish and I. Like I told you guys, we are going to have an amazing podcast on Docker versus Podman. We have our guest with us, but yet we won't introduce him yet. Just give us a second, we introduce the topic. So Ish, have you ever used Docker?
I've used containers, and coming to Docker specifically, I used it against my wish a couple of years back.
Against your wish. Maybe you can discuss that later. But yeah, many people think that Docker is equal to containers. Like I told you, like I asked you, Ish, have you ever used Docker? Maybe I should have asked Ish, are you aware of containers? Have you used containers? Because like we know, Docker is just a container management tool. Correct me if I'm wrong. So yeah, what about Podman? Podman is another container management tool, which is I don't really know about Podman. I've never used Podman. Maybe Ish can tell us a bit about it.
All right. When you started talking about containers, you used the term container management tool. Okay. In fact, when you talk about containers in general, you need to be how do you call that? Make a distinction between a container image, container management tools, and container engines. All these have different tasks. Okay, and without spoiling the fun, I think I will let you introduce our guest because this topic about container management engine, container management tool, and container engines, container runtimes, container specifications, container images, all these different topics would be something very interesting for us to hear the opinion of our guest. So without wasting any more time, let me just switch and put our guest on screen. That would take a few seconds. And then Girish, it will be your task to introduce our guest.
Okay. Yeah. Okay, so our surprise guest is with us, Rangan. I don't think he needs an introduction. He has already done some talks on DevCon. But yeah, Rangan is a DevOps engineer. He used the containers a lot. And when I was first learning Docker, he even taught me some things, some features on containers that I read after that. Maybe Rangan, can you talk a bit about yourself first, and then we can start the podcast.
Okay, before I start, I must say le retour du comeback numéro 2. It means I'm back again. I was supposed to only give one talk, so le retour du comeback number 2. So, I've been doing software since 1990. And I've seen many things. So right now, the only two things I've not done, and 2 or 3 things I've not done is AI, blockchain, and what is it again? I think it's the only 2 I think I've not touched. But you got the gist of it. And lately I've been doing, I've started my new career as a DevOps engineer at Worx. So we are going to do something interesting there. So I can't say more. Integrity and secrecy oblige. Donc this is it. And and to answer your question, Docker and containers has been like a mystery for me for many years, like many of you guys. Then one day I woke up and started to get things done in Docker and learning it, and learning it, doing things with it, playing with it, doing something's dirty with it, and other stuff. So back to you.
So, yeah, actually, containers since long. We have Linux containers, RKT, Kata containers. We have BSD-JS. I don't know if you can consider that as a container-ish. Can you talk a bit about that? The old containers.
Well, when you talk about JS, the concept is similar. And if you, sorry, 1 second. Every time I switch, my microphone goes a bit nuts. Yes, when we talk about BSD jails, the concept is similar with with containers. If you go back in the history of Linux, then you will realize, and Rengen will agree with me, that containers is nothing new. It has been around. The concept has been around since very, very long time. I might even say, Rengen, correct me if I'm wrong, since you're older than me, maybe 3 decades ago. The first sign of isolating programs on the Linux machine was with chroot, all right? Then around, I think it was Linux kernel 2.6 for something, 4x maybe, or 3x something, that Linux namespacers entered the kernel. It is only there that the container world becomes serious, okay? Because even then, containers were not yet invented. The concept started, brewing up.
The main idea started in, I would not say that years ago, I would say more like 25 years ago, but you get the gist of it. So isolation of, in fact, before we can go even to containers, we should say that the concept of isolation goes way, way beyond 3 decades. It's like 6 decades ago. The concept of isolation, and this is a thing that most people forget. It's about isolation.
Yes.
When something blows up, it only blows up inside something, and it only blows up. So the concept of isolation was there. It has taken roots in object-oriented and all these things. But in infrastructure and operating system, it was there for many, many years. I think I can boldly say it even started in before Unix. If I can even go back in this Multex. If I can boldly say that.
Okay, so yeah, we have many people that actually, when we talk about containers, the only things that come to their mind is Docker. But there's also a reason for that. When Docker was out, I think it was 2013. Till now, it has been
was still beta 2013.
Yeah. Okay, so when Docker came out, let me put it like this. When Docker came out, it was widely adopted. It was the first container management tool that was widely adopted by many. We can say that it was it is the first container management tool that was widely adopted by many. What are your thoughts about that? Why was it Docker? Why was Docker adopted by many? What was it about Docker that made it, I don't know, interesting or what?
Yish, you want to answer first or I answer first?
Go on.
Okay. I mean, the reason Docker was ease of use. If you compare how Google gave C groups to the Linux community, and what Docker does, all these things which is what is done by C groups means control groups, and all these underlying machinery, Docker has like put a synergy around them, put an interface, a REST interface around them, because REST interface and microservices work hand in hand, and it have like made a very good abstraction of it, and it's so easy now, even a layman can just create a Docker image. When I say even a layman, it's not saying it in a reductive way. It's saying that you do not need a PhD to create a container. So what I'm trying to say is that the creation of images, of Docker, once you get the gist of it, it's easy. Of course, there are some mechanics inside. When you have to get your heads dirty, it becomes complicated. But if you want to deploy a container, you don't need a postdoctorate or a PhD to do that. It's like the same success like MP3. If you wanted to have a song back in the 90s, late 90s, all you take, it was a CD, you rip it, you have MP3. That's why MP3 became so popular. And MP3 was victim of its own success. And this is, I think, what has happened to Docker lately.
I will bounce on something that you said, and I agree with that part, that the major adoption of Docker was thanks to the ease of use. And if you go more specifically about that, it's the container imagers became portable. The having the ability to take an image from somewhere and sending it another place and spin up and have your isolated environment. This is what made the success of it. And then you had Docker Hub, where developers could just tinker around and publish their container images. These made adoption of Docker extremely easy. Because if you go back in those days, you had Linux containers, LXC. LXC was there. But LXC was not as easy as Docker for developers to start using. It was more a system administration tool. System administrators could, go around on the VM and do the isolation part. Docker, when it came, it became like the work that sysadmins had to do, the developers themselves could start doing that. Would you share a similar thought, Rangan, on this particular topic?
Because I started many part of my career I'm still a developer because I like writing software and maintaining software. So this is for many months and years.
Will you just give me 1 second? I didn't realize it started to get a bit dark. I'm just gonna switch on the light. You go on. I will hear you.
Okay. So where was I? Okay. For developers, I share similar thought with him because before that we had VMs, and if you had to orchestrate VMs, you had to know Vagrant and all that kind of stuff. And then I can tell you, Vagrant is not easy. Docker, apart from being ease of use, there was that Docker Hub who looks like a torrent website in which you can share your stuff. It looks like a torrent website. You want a Docker? Just download that Docker, and it's going to install in your place. And one more thing, that portability. I would like to also say the first part of Docker the first 4 years Docker was on Linux only. Then later on, it became available on many other platforms. When I say Linux, it was mostly like Linux and Mac OS. And later on, it was adopted by Windows. So you can see that now it's like playing a game. You want to play a game from Steam, you download a game and you play it on any platform that you want. It's the same idea. You want it, you play, you download it and you use it. And this is the main idea. And this was a key for adoption. And also it was free, not to forget.
Yes, yeah. I agree. Well, I agree with that.
If you talked about it, something came to my mind that we have now. Somebody calls that, Windows subsystem for Linux. I know it's going on a different path, and Ish and I already planned a podcast about it. But Windows idea for Windows subsystem for Linux is to get developers their tools to get running, and that WSL, Windows subsystem for Linux, is now running Docker backend. At first, when Docker came to Windows, it was actually a VM running on Hyper-V that would run the backend. It was a Linux VM running on Hyper-V that would run the backend of Docker. But with WSL2, with Windows Subsystem for Linux, we now have a kind of, it is a virtual machine, but it's by Microsoft. It doesn't take like an overhead of virtual machine. Like, for example, if you have to fire up a virtual machine, you will need takes like the boot time and everything to load up and blah blah blah. But when you look at WSL, it's like opening a terminal and getting started. That's how quickly Docker starts now on Windows Subsystem for Linux. This was a thought to just get developers to work on Windows. So I think that containers, and especially Docker, was kind of widely adopted because of its ease of use, as you said, and also the platform compatibility. Everyone made it easy for them.
Also being free. Free, don't underestimate the power of freedom, of free, or something being free. Don't ever underestimate that thing.
Yeah. Yeah, okay, so
yeah,
let's move on.
Rangan, I would say the last sentence of yours is quite debatable. Linux has been free for 3 decades now, yet it has still not been widely adopted as a desktop. So it is debatable.
Desktop is started in Linux like 20 years, not 20 decades ago. 20 years. 20 years.
Okay, I will agree with that because the first 5-6 years it was not usable as a desktop. Okay, I give you credit for that. But my statement still stays that having something for free might not always necessarily work and be the reason for a wide adoption.
Okay. Let's to close that sentence, because remember we have a debate Podman versus Docker, and not a freedom.
We'll talk to that in a few minutes.
But the only thing I'll just conclude on that, Docker is already for what we call skilled people, whereas Linux is not for skilled. Is still for skilled people, not for the layman. That's why it's difficult. Docker, this is the free applies there.
All right, let's agree to close the topic on this note. And before Girish goes on, Girish, do you allow me to ask again the next question and bring it directly? Okay. So
maybe you could talk Podman first. Tell us our thought, and then we can ask.
Well, instead of telling something about Podman, it will be more like a technical talk. What Podman is, a daemonless, blah blah blah. I would say let's directly come into the topic, because otherwise we will run out of time. So, Rangan, my question here, and it's going to be a debate, all three of us, is that Red Hat, and SUSE, two of the major commercial Linux distributions, since a few years now, have been working to move away from Docker and adopt other container runtimes. For example, Podman, CRI-O. What are your thoughts on that? And according to you, what might have triggered this move in the industry?
Okay, first things first, it's the same debate that we had like for the UI. Back then we had KDE, then they said there was need to a genome, then it became something. Because competition is good.
Mm-hmm.
And as I always say, not always, but I say often, be careful of the man of one book. So be careful of only doing only one thing, and you will lose a diversity of ideas. So if we all just do Docker for containers, so Docker will be like the Microsoft of the 90s. So whatever they say is going to be the word of God, and you can't contest that. So now what you say, there are competitors. It's a good thing, because right now Docker containers, the way I look at it, is very generic. Because what the usage of a Docker for big data, if you want to do some processing, you want to do some mining, you use the same Docker. You use the same Docker, you allocate the resources differently. But what if we could have a Docker what is specialized to do mining and to use the resources of a GPU and not a CPU? We do not have those right now. So we depend on the application and another container. It could be like more massage, more specialized to do those kind of things. It would be good. So if we can get that through competition, it would be good. It's a good thing. I'm not saying, and if we could get lighter Docker lighter containers, it would be good. I'm not saying serverless, because we know the debate on serverless.
Yes. Let's not go down that road.
No. What I'm trying to say is that it's a good thing. First thing, it's your first part of the question is a good thing. It is a good thing. And the OCI was given by Docker. I don't think when they created that we expected to get competition. Now it's coming back to bite them in the way.
OCI was donated to the Cloud Native Foundation by Docker. By the way, I think Docker is a member of CNCF.
Yes.
Okay, and still though they are competitors. But my question, if I bounce back again, my question is more like, commercially, does it make sense for these two big Linux giants to go and redevelop something rather from scratch? Or why not just continue the development on Docker and contribute upstream?
Okay.
Because I'll continue on this part so that you get a gist of what is in my mind. Because from where I stand and I look at it, most of the open source projects, when there are forks, okay, the fork does not just happen to improve a software. Most of the time, it happens because of disagreements in a community. Like, for example, Rengen maintains an open source project. I contribute to that project. But then one day, Rengen decides to do something that the rest of the community, including myself, we do not agree with. So what we say, Rengen, the project is open source. We're taking a copy of it as it is right now. You can do your modifications the way you want, but we are going another way. So I believe that somewhere with the success of Docker and Docker being adopted by masses, by large corporations, a lot of the companies wanted to do things differently. And this statement about doing things differently was not, agreed by those maintaining Docker, because again, I've seen some comments on GitHub on the contributions where I forgot the year. Red Hat wanted to contribute a few things to Docker, the way they wanted to do, the way the Docker CLI could query a remote image, but those changes were not accepted by Docker, by the Docker community. And it forced Red Hat to go and develop another tool. Well, I think after that, Scopio was invented, and even Builder was created much later. So, to sum up on what I just said, a fork of an open source project mostly happens because of disagreements rather than because somebody wants to make it better or something like that. Maybe both of them are doing good things. Docker is doing a good thing in its own way. CNCF, with all its members, they are doing a very good thing, including Google, a good thing with Cryo in their own way. It's just a matter of disagreements.
Okay. Docker, I'm not trying to sell Docker to anybody. I mean, we have marketing for that. Docker also gets its good thing. It's massive. It's a one-stop shop. It is what we call big fat daemon. It builds, it orchestrates, it pulls images, and it orchestrates by orchestration. I mean, it runs the Docker image. It has to schedule which Docker image get which memory, which CPU at which point in time. And those two companies like Red Hat and SUSE have gone into the Kubernetes space.
Yes.
So, and they don't need that orchestration given by Docker.
Yes.
They don't need that because their Kubernetes is doing that for them. So for them, a huge part of this big fat daemon, they don't need it because the Kubernetes is doing that for them.
In fact, the part big fat daemon is what is being used against Docker.
Because it's a one-stop shop. I mean, it's like having a big. You might say I'm doing politics. It's like having a big institution, but it's doing everything and it's not doing it right because it has too much responsibility. And this is one of the big issues. So the philosophy of open source is if it's too big, or even right now with the philosophy around software is if it's too big, if it's a big monolithic, break it into smaller pieces, and we call that thing microservices. So they started to break it into 3 different tools. In fact, if you take those 3 things, Builder, Podman, and Scopio, they are like the 3 lions of Voltron, and when they meet, they become like Docker. It's like and for those who know Voltron, I hope some people know Voltron. Except in Voltron, you have 5 lions. Let's say here we have 3 lions. So So the trick is they have started to say, okay, not big fat demand, let's split it. And they don't need that orchestration kind of thing, but run. They only need the runtime, and the runtime is just container D. That's all they need.
Exactly. We can go even at a more tiny level. Just use runc. Okay. In fact, you can even use runc without Podman. You can create the container just by using the runc program, the utility. Yes. Rather than Podman calling runc to create the daemon, not the daemon, sorry, the container, and then hands it over for Podman to use to hand it over in turn to Conmon, the container monitoring tool. Whereas in Docker, you have, like you said, the big fat daemon. And it is a daemon, which means that even when you're not using it, it is running. On the contrary, Podman is there. It is a binary sitting somewhere. You have runc. It is a binary sitting somewhere, not consuming memory per se. It's only when you call it, you say, okay, Podman, I need you to pull this image, and you need to create a container with that, and then you need to run it. Then only resources are being consumed. Whereas in Docker, you're not running anything, but the daemon is there. It is consuming the memory. So the big, like a few minutes earlier, I said the big fat daemon thing is working against Docker actually.
Mm-hmm. Yes, it's as I said earlier on, it's like victim of its own success. Now that everybody's using Docker, just like MP3, so they cannot improve much now. They are like stuck in like they are victim of their own success. They are kind of stuck. So if they want to break, they will have to take what we call the very, very important decision and the very courageous decision and say, okay, we are too fat now, we need to split up. So, but they have not taken that decision. So others have taken that decision for them. And others have also vested interest. Let's not blind ourselves and say they have also financial interest. And because we are not selling containers, we are selling what we call orchestration system. We are selling you cloud-based solution. Whether they are small or the big, so we are selling you the OpenShift, we are selling you Cubic, we are selling you Rancher OS now. SUSE has acquired it. So we are selling those solutions. So they don't need somebody to orchestrate the containers. They only need to build the containers, and they only need to put in a registry and to push and pull from a registry, which they think they can do a better job because now that it's split. Okay. I will just finish that on 1 minute. Yeah, there is one problem with Docker. I have been through that. Everybody now do CI/CD, and many now and then people have agents to do that CI/CD. And you want to build a Docker image. Now most of the agents now, if you want to run them, you have put all your licenses in it. You want to put that in a Docker image itself, so that you can push it on Azure, you can push it on Google Cloud, you can put it on your own machine. So it's now you put your agent into a Docker. Cool. Now you need to build a Docker image because those agents now need to build Docker image. So now you have to call a Docker inside a Docker. And I've done it. And I can tell you, you need kahunas to do that. So, but I'm trying to say, it's not easy. And all you wanted to do, you don't need the runtime. You don't need to pull the registry or push into the registry. You need to build a Docker image, and you don't need the fat. You only all the fat that comes with it. You only need to build a Docker image. So this is the part where I think where Docker is failing a bit, because now you have all this complexity that was not thought about. Like remember, they invented history. They were also victim of it. So they don't have anything to use as a lesson. So okay, this is my bit. So this is, you can continue, Ish.
Yes, I agree on the last part that you said, but I will bounce a few sentences before that, where you said that, okay, CNCF, OCI, the big Linux giants, including Google, they are doing things their own way. You have Podman, Builder, Scopio, runc, different tools, and Docker hasn't gone that way. It has stayed a big fat demon. Do you believe that if the Docker community right now, they vote and they decide that, no, we are going to do it the CNCF way, would that become a tough competition for the rest?
Yes.
Because keep in mind that today, Cryo, Containerd, Runc, all these projects, all the different components of Kubernetes, including Kubernetes, are projects under CNCF. All right? So
Yes.
they have a major commercial backing. Because the CNCF, when we say CNCF, we are talking Red Hat, we are talking Google, Kubernetes, I think there is IBM, you know, the big,
Microsoft also involved.
yeah, the big software giants. Now, Docker has to compete with all of these by still being a member of CNCF. So if the Docker community decide to say, okay, the one thing that is playing against us today, and the one thing that because of which most of these software companies went away, if we do it, will that be a really tough competition for the big players? Especially Red Hat, which has invested so much into improving Containerd, into improving Runc.
So let me put it the other way. Let me like what they say. If it is working, don't change it. You know that there are still some companies still using software written in C# 1.0 in Java 1.4, and it says a lot. And it says a lot. Some code are even running in Python 2.7. That's why some people in Python doesn't having lots of trouble right now. So now I go to the point. As you know, in software, we have that saying, if it works, don't touch it, don't break it. And many people have done that because you have that safety that it was working. So there's this with Ben, there is what I've been looking at, let me, so that I do not, there is, Podman doesn't suppose C Group version 1. Some people are still using legacy. Remember, I mentioned those legacy on purpose, but I let you know. Ben, there is that thing what you talked to me about the daemon. The daemon is running and you are not using it. It's just for every daemon, it's the same. You have a database. Everybody who just installed a Ubuntu 20.04 on his machine can install MySQL, and they're not even using it. It's just running there. So again, it comes to skill and all that kind of stuff. So what I'm trying to say, Docker, most people will, if they install Docker, they're going to use it. Whether it's running and it's just running a pod that just does hello world, is going to run. And you can switch it off anytime you want. So it's the same for an Apache daemon and blah, blah, blah. So I'm not going to try that. So let's come back to what you just said. Is Docker going to be a competition? Yes. Is it going to be a very tough competition? But I can't say. But remember, they have a lot of legacy. They have proven themselves. Podman has to prove himself. Podman is working very well in OpenShift. Supposedly, I know some friends have got some problem with it, but I will not expand on it. Mm-hmm. Docker proved itself. Has Podman proven himself? That is a question. And remember, in software, if it works, don't touch it. You still have COBOL code still running. Huh? We are looking for COBOL developer, and they pay very, very good money for that. Huh? I'm sorry, I abandoned COBOL like 25 years ago. So I don't make myself. So my answer still stays. Docker has been used, and even if you have better competition, Docker is still well used, and people like the ease of use of it, even if it's not very performant. COBOL is not performant, still being used. Python 2.7 is not performant, still being used. So here's my thing. Most people are reluctant to things that they are used to. It's something about human nature. Mm-hmm. So this is the first part. And Podman has yet to prove itself. And Podman has vested interest because Podman is not supposed to be working on its own. It's supposed to work in Kubernetes. So if someone is going to use Podman, they need to also do Kubernetes at some point. But if you're using Docker, you don't need Kubernetes for your ingress and what. Okay, I stop here.
I will correct you on the last sentence because okay, I come from an OpenSUSE community where we have different distributions for different needs. For example, if I think, are you guys getting an echo with my sound, or is it okay? It's okay. I just heard an echo.
You play with it.
Okay, sorry. So yeah, what I was saying is that the OpenSUSE community, we have different distributions for different needs. For example, if you're running a single machine for your production containers, maybe you have different applications that you're going to deploy using containers and blah, 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 but you are not planning on scaling up because these are single applications, maybe different applications, but single applications that are not going to grow over time. Why do you need Kubernetes for that? You don't need. So OpenSUSE has this project called MicroOS where it runs only Podman. You don't need the whole, Kubernetes and the master and different nodes. You have Cubic that runs Kubernetes where you need a platform that you intend to scale up at a later stage. Now, it can happen that at the beginning, you said, no, my platform is not going to grow. I'm a small company, blah, blah, blah. I'm going to use MicroOS with Podman. Okay? But then after some time, magic happens. God blesses you. And then your company grows. Your infrastructure grows. Number of servers increases. So now you need to migrate from here to Kubernetes. How do you do that? Do you know that Podman can export all your pods and containers in a very well-structured and Kubernetes compliant, not Kubernetes, but OCI compliant YAML file that you can directly import in Kubernetes? Even if you're not using Cubic, maybe you're using OpenShift, you can still import in them. So this concept of use Docker if you're not planning to grow because you don't need Kubernetes, I don't really agree with that. For me, I don't say I hate Docker. I just say that I'm not a fan of Docker. I like Podman. I like the easiness of Podman. That like a couple of minutes earlier we were talking about ease of use. For me, Podman, the ease of use that comes with it, I find my comfort zone there.
Okay. Again, you're talking from a
wait, I think Girish has something to add.
Yeah, sorry. First thing I would like to I didn't get a chance to answer Rengen before. I think Docker is working on Docker in Docker.
Yes, it was. But it's not that back when I was doing it, it wasn't that easy. I'm just saying. I'm not saying I did not do it. I just said you need kahunas.
Like again, Docker inside Docker does not happen like this. Some time back. Does not happen like this.
What I said.
The second thing is when Ish told us that you can easily transfer your files from configuration files from pods
to the containers and pods from Podman to Kubernetes.
We have something called Compose that translate Docker Compose files that runs on SWAN to directly Kubernetes. We do have that. I will share something with you.
I would not really adventure there because I don't even know why Compose exists. Okay, but it's still. Sorry, something happened. Okay, you shared something. Yeah. But it's still when it comes to Podman, the developers they do have a Python script that has been published where you can use Podman with Docker Compose YAML files. But again, I'm not a fan of that. I won't go down that road. What are your thoughts on that, Rengen?
Okay. Migrating Docker to Kubernetes like that, for me, I have my reserve on that because on Kubernetes, you have all the stuff that is associated with it. You have storage, you have network, you have your services, you have your routes, and all that. It's not just going to happen just like that. No, today. So it doesn't happen like so it doesn't happen just like that, So what you do, you will have to do some customization. This is where the DevOps people come in. So it doesn't just happen overnight or just happen like a snap. So what I'm trying to say, you will have to do some work. There's not something like a free meal. And if you're trying to sell you that, okay, Microsoft sell you click and install like 2 decades ago and it never worked. So what I'm trying to say, everything that does like seems too easy, it's a problem. Things needs to be easy, but not easier than it has to be, like Einstein said. So what I'm trying to say here, you cannot like move from say okay, let me reshuffle my ideas together. When I said that Podman was built for Kubernetes, this is what I meant, because Podman is mostly a runtime for the containers, and it was meant not to you can use it in isolation, but it's not built for that. But Docker, when it was invented like 6-7 years ago, it was meant to run on its own. So, and Kubernetes and all that, we adopted Docker because it was a popular kid of the lot. But Podman was developed with Kubernetes in mind. But in my mind, this is where the divergence comes. But in my mind, this is where the best interest comes.
Exactly, I agree with you on that.
This is what I was trying to say. And having Podman and having both these companies, they have vested interest in Kubernetes. Kubernetes has won the orchestration war. Has won.
What you just said about vested interest, I think it concurs with one of our viewers' comment where he says that Red Hat wants the fat enterprise support contract cash.
And that's why IBM bought Red Hat.
Yeah, it concurs with what you just said about the vested interest. So do you think it is an attempt to kill Docker?
I mean, there was attempt to kill Linux. There was attempt to kill yes. And remember, Microsoft used to call Linux a communist, a cancer, and all that kind of stuff. Now they embrace it. And remember, now we have the reverse way with Docker. They embrace it. Now they are saying it's bad.
Yeah.
Now with Docker, it's kind of the reverse.
It's funny on the line that I think it was Paul Allen who said that in one of the conferences, I forgot where he said that, Linux is a cancer. But years later, the tagline is now Microsoft loves Linux. So that's really ironic, right? Anyway.
Yes, but you get the same. I say with Docker, we went the other way around. They embrace Docker. Now they say, oh, now it's a cancer. So you can see it's like it's a bit like the irony of life. Okay, when you say Podman has, for me, I will. It's not that I will not, because you just rename Podman. You just adjust Podman to Docker. You will have more or less the same commands. And I've done it in some of my distribution, on my distro that I have on my machine. I've done it, but it still have to prove itself on real battle, on the battlefield. And for me, I have a few friends that uses Podman and IQera IO and that kind of stuff. They are having some nightmares. And but with Docker, they did not have that. So even though Docker has all these problems, a big fat demon, blah blah blah, and all the curse of the words being sent to Docker, but Docker still works. And that's a good thing. And something in technology, there's that thing called a heap. It's called a heap, and everybody runs it. So for me, Docker is like many technologies in our industry, like many fads, or in our industry, we have more or less love stories. It starts like, oh, we can't have like enough of this. We need to date each other. We need to go dinner with the technologies. We need to go to conference. This is what a conference is. It's like going to dinner with a technology. It's like quoting a technology. This is what a conference are, for example. And this, you do that, then there's a marriage part where the thing becomes boring, because marriage is boring after some time. And you must you must know that.
Well, no comments on that.
and nothing in Docker, we have reached that part where we are at the boring stage, because most of the stuff has been polished, many things have been tackled, but there's still work. There's still work to do. I'm not saying it's not. Now it's a big fat marriage. Now we need we maybe to split the family a little bit. But will Docker go away right away? Because people have saying Docker will die for the last 3-4 years, and still here. So let's wait and see. And my take on that is that there is WebAssembly, which Microsoft is working on, WebAssembly with the OCI interface, the OCI protocol, so that Instead of having a container, you have now having a WebAssembly running. This is I think where we have the real power. The podmans, the builder, they are incremental on top of Docker, on top of containers. But WebAssembly with RESTlet and being OCI compliant, that for me is something I'm keeping my eye on, and not podman and the rest. If you ask for my opinion.
Rangan, on that note, I would say that it is 17:46 hours Mauritian time. Girish, we're reaching the end of the second day of the Virtual Developers Conference 2020. So, Rangan, I know this topic would go on and on and on. We could talk for more than an hour, maybe several hours, and probably over a beer after the conference. So I will leave it to Girish for some closing remarks, and
Do we have question? Or all the audience have
no, the podcast was mainly about asking people if they have questions, comments. It was rather, we had only one comment, and I guess at this time people are, leaving office to go to home, so probably a lot of them are, commuting. Anyway, the podcast is going to be on YouTube later, and then we are going to look at the fun in the comments, and we can take it from there. Girish, I leave it to you to make the closing remarks and end the show.
Getting on board. I just listening by you guys, I learned a lot, and that's how it is during each of our meetups with Brangan. It was really nice to have you here, and yeah, even I learned a lot. So it's great.
All right, guys. Girish, thank you very much for being such an awesome co-host on the second day of the Virtual Developers Conference. Rangan, same to you. Thank you very much. We'll see you all tomorrow morning, 9 a.m. Mauritian time. Bye-bye.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
21C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Consider it done.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail, and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched a data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Tickle and Girl Code, and run a hackathon with gender-based violence to define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.